Men vi får vänta en minut.
Vänta på att alla
Ska sätta sig, ja.
byta sina platser.
Ja.
Nej, jag tror vi har plats nu. Ja, men då börjar vi då.
Ja.
Hej och välkomna allesammans. Hi and welcome everyone. My usual mistake. Starting Swedish. No. This is the second event of the type Speakers Corners that we're making. And it seems to be a very popular kind of event. We will show you some of our other events later on. This is an event where we invite people from the AI and machine learning community to come and present just in short bits, 10 minutes, what they are doing, what projects they are working on right now, to get a nice overview of what's going on here in the southern region of Sweden.
Yeah, so a small brief presentation about AI/ML in our lovely Öresundregion in Skåne. Yes, and so our second event, we're going to have more of those. Next one will be in Prisma. This is here in Helsingborg as well. And today we are actually in Helsingborg, for all of you who are online. So we are being live streamed by Joachim Jardenberg. Yes, there are plenty of channels out there streaming this event. We have our Barrel.ai channel. We just opened it and we have 130 subscribers. Hopefully many more after this event. So for all of you who want to basically share this event, there is also this one. So you can take a picture here and share on your social media accounts. It will be nice so people can actually hear all those lovely AI/ML stories that we're gonna have during the evening. Yes, do we have anything more to say about this? Joachim, you have our own channels as well that you're standing, so it's going to be a lot of followers tonight. All right, so we are here in Helsingborg and being hosted at lovely Hobbygo Works. So will somebody from Hobbygo Works like to come here and just...
I'm the lucky one.
Yeah.
So you're very welcome to be here at Hobbygo Works. And I'm a bit curious, who has been here before? So some of you have been here and some are new. This is a place for, first of all, for the colleagues in Helsingborg Stad. Am I in the right position? So everybody can see me. We are 10,000 colleagues in the city. And at this place where we are 50 colleagues, we work with innovation. So you can come here if you want some support. And we work together to get good solutions for our inhabitants. So we started in February last year, and now we're aiming for H22, and the smarter city. So if you want to come here and do good things together with us, you're welcome. The door is open. If you manage to come through the first door, the door here is open. So you can also follow our work at Hobbygo Works and also Innovationsdatabasen. Now it's a bit Swinglish, but I think you get what I mean. And just knock on the door and search Hobbygo Works, and I think you will find the way to us. So very welcome, and I hope we'll get a good evening together.
Yes.
Thank you.
Thank you, Lisa. I'm sure we will. Yeah. And thank you for the pizza and everything, which it will be served around 7-ish. So, yeah, and all the snacks and soft drinks. All right, so Barrel.ai community, just a very brief presentation about us. We are a pro bono community, and we've been around for a couple of years now. So founded in 2017 by a couple of us ML AI enthusiasts that kind of urged to become more professionals, so to say. Yeah, and basically, I mean, we also have some new coordinators lately, Isabella and David. Just sitting here helping with the things, and we have 720 members counting, and not all of them active, but we do have some. Yeah, Emil here sitting is with us almost in all events. And, yeah, So very much pro bono. We try to kind of connect like-minded people who actually want to either share their professional expertise within the AI ML field, or people actually just interested in kind of learning more about this field, but also making a lot of connections. So it's basically, we also say that it's an ML geeks community by the geeks for the ML geeks. Yeah. And
yeah, and we have had a host of different types of events as well, because we want to engage the community, and AI ML is a broad topic. So you have discussions ranging from the hardcore tech, how to build a neural net, to how will this affect the society. And therefore, we are organizing workshops where we get into the nitty-gritty of the code and try to build stuff, competitions like Kaggletons, where we also dive deep into building solutions. Other events has been after works, where we kind of get together and invite other people who might not be as techy, but to talk about different solutions and how machine learning and AI will affect society in the future, and how we should proceed building AI solutions with the tech we have. So
yeah, I mean, we've been having quite many different ones, even like being on the big conferences like Copenhagen Tech Festival.
Yeah.
And focusing more like on specific industries like fintech, together with AI. Öresund fintech is not exist anymore, but agro-tech, critical tech.
Looking at different niches.
Niches, yeah, where you can actually apply AI ML together with our Barrel monkeys. Yeah, I forgot to say, you realize that we have this one, so we call ourselves Barrel AI monkeys. Yeah, and so are you now, all of you sitting here, our members. Hope you don't mind.
And now the latest contribution, our speakers' corners, where we invite people to do small pitches.
Small pitches, yeah, but very useful because, I mean, we'll have some longer ones, and we also plan to have more like Kaggle-oriented competitions as well in the next year. So, yeah, stay tuned with us. There are many more things are around the corner. But we would like to point out the values we actually create with our community, because after doing this for a couple of years, we do realize that we are creating value, and we love it. I mean, we do it by our heart, it's a pro bono thing. And of course, we are bringing together experts from Skåne and Öresundregion together to collaborate on a very interesting projects and then competitions. We also kind of allow them to share you guys to share your insights and knowledge with others. We encourage enthusiasts, basically maybe not experts, but people who would like to advance in the field, to advance their skills. We help them move forward. Because tonight we'll learn a lot about AI ML, everything from NLP to CNNs to landscape here in this region, and how to build a data science team in a startup, many different things. We're also connecting regional AI ML experts and enthusiasts with the public and private sector, and promoting regional AI ML startups, of course. And by all this, there is a kind of derivative out of this final result, is that we actually encourage people or young professionals to actually stay here in the region and not fly away to Singapore and Silicon Valley. I'm not saying it's bad there, but we like to keep people here, all those young professionals. And of course, I mean, we are boosting this development in the region by doing all this. So yeah, I mean, I'm giving us, like this now. But yeah. All right. Any questions so far about our small community? No questions. But then we have a lot of, there's probably a lot of questions on the topics. So yeah, we are already done with the presentation. So we have a couple of preachers that will share their stories. 8 of them. We actually had to say no to 2 of them that actually called us today and asked, can we just drop in last minute? The idea is actually it's going to be a little more like freestyle. People will be able to, just, go go to the speaker corner and preach, but it just happened to be the case that we got so many interested, pitching booked in advance for this one.
It's too popular.
Yeah.
What can we say? Yeah.
All right, but we have 5 responses, which are, we will start with Erik from Sweden AI, over to Bente from Hero Loop, then to Ray from Malmö Stad, and Isabella from Daxon, Marcus and August from Lunds University RISE, Joachim from Get.ai, Emil from the Brict, and David from Daxon, that will, and they will talk about those subjects that you see here. Very interesting ones. All right, that's all. So, should we start?
Yeah, let's begin.
Let's begin. Erik, I'm going to open your presentation here. So.
Warm hand to Erik.
Yes.
Good. So I'm an example of a young professional who stayed in this area. My name is Erik Winston, and I'm working for an organization called AI Sweden, which is partly governmental funded, but also funded by partners and regions like Region Skåne. And there my position is, I'm a project manager. One of the projects I'm managing is this, where we're building what's called a virtual testbed for a new type of technology, data sharing technology called federated learning. So this is what I'll try to educate you about, what we're doing there, and the potential of this new technology. And why it's so interesting, because as a data scientist or engineer, you usually sit in this position. You have a lot of data on your table and you see potential, and you go to your manager who says, stop. We cannot really apply any interesting algorithms or share the data with anyone outside our organization, because everyone are afraid of doing wrong. So that's sort of the culture of in Sweden. We have something, an elephant in the room called Gdpr, which is, I think everyone is familiarized with by now. And why we are afraid is because to enable machine learning, it does usually look like this. Where you need to centralize the data to do your modeling. So you need to give away the permission of the data. But with federated learning, the trick is that you instead decentralize the learning process. So you send the algorithm out on the servers in the so-called data silos, where the engineer, you don't see the data, only the algorithm see the data. And what you send back is the weight of the model, which you aggregate in a main model. So we hope that this will be a workaround around GDPR, because you actually don't touch and see the data. You only get the result of the, as you have seen, all data, but not. So this is what we're looking into. How safe is it? How do you work with the technology? And what can you do and what can't you do? And why this is so interesting is because it's decentralized and we think it's privacy by default. And so within federated learning, there's 2 types of main categories. One is called cross-device, and one is called cross-silo. So cross-device is, for instance, if you're using an Android phone and have Google Keyboard. This is enabled because Google Keyboard learns from millions of devices on your device and try to predict what word you're going to type, but without violating your privacy. So if, for instance, if you're writing sensitive words, it's disguising it or leaving it as an outlier, doesn't include in the big data pool, so to say. And then cross-device, which is can you incorporate, for instance, in hospitals, can you work with hospital data in different regions? So in Sweden, the hospital data is pooled in different regions, where Region Skåne, Region Halland, and no one wants to share health data because that's the most secure data there is, or so to take with you here is that you have 2 cross-device and cross-silo, and cross-silo is what we look into the most because that's something we can touch on. You have your data in silos and you don't want to share it. So one example is with the hospitals, and one is, for instance, if we could start sharing data between public organizations, for instance, to fight eco-crime. So usually the tax agency has some data, then it has to go to the police, they have some data, and then you need to check with Bolagsverket who's managing if you have a company or not. And today they're not really sharing data. So we hope that with this technology they can work across the silos. But here at Barrel.ai, we usually tend to look at or think about the technology. But if you're gonna work in the real world, you also need to take several other layers into aspect. The privacy aspect, actually from training a model, will you be able to trace the data points anyway with cross-linkage, for instance? Or do you have to enable different privacy-preserving techniques like differential privacy, where you flood the data with noise? And also the legal aspects to be able to share data between other organizations. So here's an image of what partners are involved. So HPE is trying to establish themselves in Sweden. They have a framework who solves this, and also an organization called Scale-Out. And then with different partners, they have different use cases. We try to enable the technology on those use cases. And I've listed them in this manner. So that's how we work. So this project spans from August to end of March next year, for roughly 8 months, where we received 1.5 million crowns from Vinnova. So Vinnova is sort of the Swedish innovation agency who tosses free money onto projects that they like. That's usually how you explain it from a startup perspective. And we categorize 4 POCs that we're running and connect different resources. So one example is, for instance, Region Halland, together with Halmstad University, who has what's called a mortality prediction module. So if you have visited the emergency care, they can say with a degree of certainty if you're going to die within 30 days, which is rather depressing if you think about it. But then it gives them the chance to add resources to those cases that are in the red zone, so to say. So that's sort of a good example, but they have a problem. So this algorithm cannot be used on any other regions within Sweden, because then you need to access that data. So that's when federated learning comes handy. Can you do a combined model on each other's data, where the main model actually has seen much more data that is only enabled for Region Halland, for instance. So Region Halland is only all white men. It's very similar, whereas in Stockholm you have an international community. So the combination is much more interesting. Another use case is Volvo Cars, for instance. They have the problem that they have a Chinese owner, Geely. Hence, the Chinese market is extremely interesting for them. And to develop autonomous vehicles, you need to train on raw data. And raw data is extremely big files. You drive a video car through Sweden and China, and then you annotate the data. But the problem is you cannot take any data out of China. So how can you access that data and train a combined model? This is another example where federated learning comes in handy. Can you train a combined model where the data remains in the different regions? And this is interesting basically for any company that is going in and out of Europe, since we have Gdpr here. So they need to comply to that. So then we hope that federated learning can be an enabler to work between data lakes or data silos, so to say. So the big picture here is that at least I, as a project manager, hope that this will enable us to finally work with machine learning. Because at its now, it's all about data and who owns the data. But can we instead look beyond what can we do with each other's data, and can we create something in common instead? So that's all for me. Thank you very much.
Just to remind you, we do have like a couple of minutes question and answers after each and every session because it's very important to have. So go ahead and ask what questions you have to Eric now.
Yes, a regional question. Do you have any regional partners here in this project? It's very interesting.
No, unfortunately not.
Any plans to?
Yes, so this is sort of an ongoing project till end of March, and hopefully, ideally, it will continue after that. So we're looking for anyone interested to join, basically, who has data. So this project sort of was given to me when I started in June this year in AI Sweden. So I think that's why one of the answers why it's any regional partners is not involved. That's a good question. But then again, Volvo Cars has an office in Lund, so partly we're working with national partners. So I will stay here also to the pizza, so you can.
But I have a question. How do you compare this to pre-trained models? I mean, basically, when you pre-train models, you can actually train it in different places. You don't need to. You can reuse those. That's basically a little bit. It reminds me a little bit about this. So what's your comparison to that?
The short answer is I don't know, which is something you're not allowed to say.
Okay. You are.
I am? Okay, good. I don't know.
I should like that answer.
Yeah, that's good. So I will not wing it, but I don't know. It could be very similar, but I guess there's some limitations to that. But it's an interesting remark that can you compare this to pre-trained models? Because when you're going to decide what technology you're going to investigate in, then you should have that clearly written out. So I'll take that home with me.
On that note, pre-trained model, you often have like a few layers that are pre-trained on a set of data. So for the Chinese, Swedish car,
you train on one and then you train on the other.
Yeah, you could do that. But if you go for the pre-trained, you would have the base of the network trained on the Chinese data, and then you only train the last layer on the Swedish data to kind of fine-tune it to make sure you cover all the edges. But yeah, there are different approaches.
Yeah. But that doesn't scale so well, does it?
Depends on how much you train it. Isabella will to speak about two of them.
I will speak about pre-trained models, but not in this like serious type of problem. But I was thinking about the pre-trained models. I'm guessing that if you would make one model per say region, like Skåne, Halland, etc., they would be like a bit worse because there's less data. So with federated learning, you can access all of this data and make like one super model that's better than the regional pre-trained ones.
I think that's the main difference between kind of aggregate and pre-train some part of the network.
All right.
Good. Thank you.
Yeah.
This is a bit. This competes a bit with just openly sharing data. Do you have any pointer on that in terms of that in the long run we want regions and hospitals to share the data so that we can provide not only better models but better services overall. What's your comment on that?
That's a good question. Ideally, we would live in a world with open data.
Yeah.
I think this is a bridge till we reach that state. And I think as long as we have legislation in EU that sort of prohibits or like make data sharing more, you need to be more aware of what you do. Then this is a good bridge for that.
It could actually be a showcase to show how valuable the combination of multiple data sources is, and then that could spur the next step in more open data.
Ideally. Good. Thank you.
Yes. There's the next one. Should we just find your presentation, Bente? Yeah. We actually made it very easy. You just click here. So, Ray, where are you?
Here.
Yeah. So, all right. Let's go start the presentation. So, all right. Let's see here.
So let's give Bente a hand.
Yes. Thank you so much. I'm so happy to be here. Thank you for letting me speak today. All right, I've been a developer and architect and project manager and project owner at these huge global projects at IBM. I quit IBM and I started my own company. It's called the Hero Loop.
So I'm going to tell you what it's about, and it's a little bit. Eric talked a little bit about some things that I will talk about. We've been implementing some of those things in this webmap. So we're making an MVP. I started thinking of COVID-19. I was tired of listening to the news. It was March. I wanted to do something like make an impact. And so I thought, all right, let's create a social platform. I didn't have a team. So I started looking around and found a lot of great people around the world. From Mexico to Singapore, I've been looking around in between, got amazing team members. All right, so what is the Hero Loop about? So it's about matching help with need. So a hero is can offer help, and then we've created like the process to do that. Then we have a requester, which is a looper, we call them, because we want the hero to help again and again to keep the loop going. And it's simple as that. So our mission is to bring people together with this social platform, but also with this decentralized data. We want to keep the people they own their own data. They don't need to share any data. They're anonymous in the tool. And then we have all the data being generated in the tool that we can learn from. Just like this comment we had about healthcare. We can learn from all this data. We can share it with governments. We can share it with businesses, etc., to improve the community we live in. So our values are, we want equality, democracy, and we want data privacy for everyone. We want to reduce loneliness by connecting people. That's a huge problem, loneliness. So we also want to strive to work against these sustainable development goals that we see these boxes everywhere here in HG works. All right, so loneliness. So why is asking for help so hard? And also this getting help from a stranger is perceived as like a threat, right? One is afraid of getting help from someone one doesn't know. But also this social dilemma, I think you've seen the documentary, a lot of you. We're under the illusion that social media is bringing us together. But they're also actually making us fight against each other. So there are a lot of things happening, and also there are some things about government. They're a little bit behind in certain areas. Maybe we could help speed things up with some ideas. So yeah, we're trying to get to the core of this mental threat for our century, loneliness. And 3.8 billion people think that social media will actually substitute their real life. So we're slowly losing touch with each other, and the need for help has never been more critical. So what do we do? The opportunity. I've been looking around. I just did a simple Google search, and it said billions and billions of people are working on this already. Like in India, they have the gross value for the services sector is 55%. And you see in the US, there are 21 billion people working within this sector. And in EU, they have 13% that work with civil society. So there's this wise guy called Eric Cooper on TED Talk. He said that one of the solutions to lower our healthcare costs is volunteering. All right, so I've been thinking of all those things and started thinking about how can I help. So the Hero Loop solution is about matching people from in your community. So it's a 20 kilometers radius. You can be anywhere in the world. decentralized so that all your data is protected, it's encrypted. We'll have this sublooper organization possibility, so you can have your own company or business or part of your government or just your group where you like hang out with friends. You can have that as a space to hang. And we have this connect with circles where you live. You can like where you live, you probably have some people you want to connect with when using this, and then you create a circle and you hang out. Then we have a point system, so you can be, as a hero, you can like get to, there's a leaderboard, so you get like, if you help the most, you're like up on top of the board. And so we're wishing for the community to write a blog about these people, or we have hero coins. That's more a new thought where I'm thinking the people that are outside of the economy that don't have access to money can have a trade platform where if they go fishing, they can trade their fish with someone who needs fish and maybe get a hero coin and use it somewhere else. We have landline options, so for the people that don't have internet, don't have smartphone phones, they can call in with an old-fashioned phone. They have to verify themselves. And then speech to text will convert a request and put it on the map. And we have an AI functionality there that filters all bad use, like toxic use. If there's toxic language, the request doesn't go through. And we also have some analytics there, which you can make use of. So we're going to the great part for tonight, which is this AI toxic text analyzer, which we built. So we had a data set of 12,000 messages, ratio 60-40, 40% toxic messages. We use pre-processing, feature extraction, extreme boosting, binary classification on this to teach it. And then we use the CPUs and 16 gigabytes RAM to get an 88% TOC score. So I'll show you how it works in a little while. So we're applying that to all messages in this tool. If you write something that doesn't, go through this analyzer, it stops the request. And then, like I said, it's already in the landline to map. So we also have the blockchain part. So we want to keep everyone's data private. We want everyone to own their own data and be anonymous in the tool. So how does this work? Let's try. Let's see a small demo of it, what we built. So here you register. So we want to have 2-level verification so that we know you're a human, you're not a computer. And then it communicates with Gaia, which is a block stack database. And then it generates the secret key. And this is the secret key. It's a 12 words key. You need to say it from your computer or somewhere else. And you create your username and some data about you. And then you're ready. And you got your, here you need to just fill in what you want to help out with. So you're ready and you got you're protected. And now we'll test the AI. How does the AI work? And this is the looper asking for help. And she writes, I hate everyone. What happens then? Well, the AI picks it up. The analyzer picks it up and says, please write a proper message. All right, so get me some sushi. And then we can fill in the delivery time. And where one wants it to be delivered and how they want to pay in cash. So then it looks for all the heroes wants to help in the area you are in. And then you can say, all right, the hero says, all right, I'm on it. See you in 30 minutes. And they send it. And both needs to confirm each other to be able to have a match. So, June is on it. Yay! And they can call each other or chat before they meet in case they feel they're scared of meeting. So my team is from a lot of places, and I love them so much. We've had so much fun. They all believe in deep tech for good. So we have India, Mexico, Germany, Ghana, Sweden, USA. So in order, like when we have this diverse team, we get a lot of ideas. It's very creative atmosphere. And it's of value because if this is going to be used worldwide, we need to have some insights from people from everywhere. So how we're going to like make money with our company? We're thinking of like using this as a feedback loop to testing different things out there. For example, we can package the AI toxic text analyzer and sell that to companies or whoever wants to try to have, so we don't need to have trolls around. We have smart contracts. We want to have like a monthly pay for that, set up different user scenarios, reports. So the data generated in the tool can be like, you can have a subscription on reports for that, for insights. We have some competitors around the world, but I don't think they're into AI and the blockchain. I don't think so. I don't know. So we have a roadmap, and we're hoping that, aiming for, that we'll be ready with this MVP end of year and go to production beginning of next year. So that's us. And if you need any, we do deep tech. So if you need any help with that, we're here to help you. Just contact me. So, do I have 3 more minutes?
Well, questions, yes.
Okay.
Yeah, sure.
Otherwise, I have a video if you want. But any questions?
Aren't you applying AI when you're matching? You know, like people when you are. Okay.
So we haven't gone there yet for this release of the MVP.
Yeah.
We've only like applied it for like words.
Yeah. All right. So
Yeah.
Okay. How do you do matching now? I mean, how do you actually? So it's MVP, but it's not released live.
No, it's not released
Yeah.
live.
Okay.
And we haven't tested things, so
Yeah.
we're waiting for that feedback loop to hit us. Like, oh, this is working really well. This is not
Okay.
we need to tweak.
Yeah.
Or, like, yeah.
Okay. So that other question.
So the toxic text analyzer, in how many languages do you have?
So it's prepared for 128 languages, and we're having English first.
Okay, yeah. No, that's
So we'll wait until we feel ready to go with other languages.
Just thinking one way of making money. We were talking about Volvo and Geely before. What about big companies like that? You need to find information and help if it was be able to slimline this to work specifically with certain companies, perhaps.
Yes, so we have these subgroups, so we can like enter them in there, and we can use aggregated data to feed them with whatever they need.
Yeah.
Yeah, we can set up these subgroups. Yeah. Does that answer your question?
Yeah, it's okay.
Yeah.
I really like the idea, and it feels like you have a strong passion in it.
I love it.
Yeah, but I'm thinking I've never done anything like with communities like this before, but I'm thinking that I'm supposing that it's very challenging.
Yes.
What do you believe will be the biggest challenges in working with a worldwide community exchanging these services?
Yeah, so the thing is like everywhere we'll go, it's going to be new things happening. Like, I don't think it's going to be the same kind of problems everywhere. So we'll need to be careful where we start so we don't get run over by things that hit us. So we'll just start carefully, like going through different places. Maybe there's a special need in some area. So maybe we'll need to talk to governments. We'll need to talk to a lot of like public and private sector about where should we start. Like who needs help first? How can we do this the best way?
Do you thinking a worldwide launch, or do you think in specific markets?
We have to be careful steps. So I wish it could be worldwide launch because everybody can use this, but that will do after the MVP is ready and we've gotten some feedback. Yeah.
Do you have any competitors that you know?
Yes, we do. These guys.
Yeah. Okay. Sorry.
Yeah. But I don't think they're into AI and blockchain. Like they're not into deep tech. I haven't seen anything like that. But we are. We love it. So that's the direction we want to go in. Yeah.
Right.
When it comes to toxic language, what is sort of the borderline? How do you judge if something's toxic or not? If it's sarcastic or if it's sort of,
It's very difficult to draw the line, right? So we're just concentrating on simple language, kind language. There's so many things one has to think about capital letters and exclamation marks and lots of things that go into this abstract place of where do we, how do we judge what is blah blah blah. So I'm thinking that once people join in there and go for it, then we can gather feedback and understand more. This is too harsh. We need to lower the barrier a little bit. Yeah. So
continuous training sort of over time.
Yeah.
So I'm just wondering, the 128 languages, that means that you must have access to quite a lot of data on toxic. Is it already labeled toxic data, for 128 languages?
No, so we're going to combine these. We need to get, we start with another language, and then we get lots of people using it, and then check if it works, and then we go to the next one. Yeah.
Okay, but where did you get your data from?
Yeah, so Carol, is that what it's called?
Yeah.
That's where we got it.
Okay.
Yeah.
Cool. All right.
Yeah.
Can I ask a question?
Yes.
So on your next slide, you said you plan to open source something related to the MVP. What is it that will be open source?
Oh, everything is built on OpenShift, so it's open source.
So the toxic language stuff as well.
So everything is not open, but we're built on an open source platform because if we want to cooperate with governments and things, it's better to have it open source from the beginning. Yeah.
Okay. Yeah.
Yes.
The registration you showed in the video, there was somebody requesting help.
Yes. So it was in the beginning. It was blockchain just registering a user. Okay. After that, it was a requester asking for help, and then it said it said I hate everyone, and it said this is toxic. That was the help. That was the looper, someone who needs help. And then
somebody registers as a hero. Is a more formal procedure for that, or is it?
They have the same procedure.
Okay.
So both need to accept each other, because if you have someone who just they need to like each other. Both need to accept each other before they do something.
Like Tinder.
Yeah. It's any kind of relationship. So you can get to chat or speak, on the phone with that person before you meet them. It's possible to do that.
I don't think you need to go through the long procedure every time. You just
No.
once.
No.
Just once.
I was just wondering,
And you gotta remember those 12 words, or else you have to start a new account because it's gone forever. It's blockchain.
Yeah.
Yes.
How are those 12 words different from a password?
So
user-wise?
it's easier to remember a password. These 12 words you need to store somewhere. It's a secret, for you personally. So So with a password, you'll remember it in your head. With these 12 words, you'll have to go like, you can't remember it. You have to store it somewhere safe. So I guess that's the biggest difference. Yeah. And also it's encrypted and it goes, it's separate from the application where it's stored. All right, so it's separate from the hero loop. It's stored somewhere else. Yeah. Yeah.
All right.
All right.
I think we are, maybe we should take the next feature.
Thank you very
then.
much. Here.
So a big hand for Ray.
Yes.
Hi, Raymond Timberland is my name. I suspect I have a different background to most people here. I'm a GIS, or Geographic Information Systems Engineer, and I work in the public sector. I don't know if there's too many others with a similar background. But previously, I worked as a data and business analyst prior to my start. And basically, our project is about how we can serve our citizens better. We get in a lot of, we have an app where people report in, the bins are broken, the light is not working, I don't feel safe in this area, but we don't really work with it in a systematic way. It's kind of, we take case by case by case instead of kind of looking at it from a broader perspective. And the thing I'm going to talk most about is, I think, machine and deep learning, especially NLP, can actually help us do a better job. But the different components are, I think the two main components is data science or data management. That's the one that's going to make or break it. And then it's also the nearness to organization, that it's driven by the organization, not by me, but actually people behind it. And here's our mission. But the key line is the last line, which is that we want to create the basis for a sustainable future, which is close to the citizens. How do we reach this? It's like there's different ways to reach it, but one of the most important ways is to work with the data that we get in. And lifting this question, trying to initiate an AI project, I'm not fond of that word. I prefer to use machine or deep learning, because anytime you say artificial intelligence to management, it's kind of a freak out, and yeah, there's misunderstandings. It's kind of seen as a risk. It's going to take a lot of time. It's not going to deliver. So the way I approach it is that we have goals. Here is our goal. We had a different project where we tried to extract the vegetation with LiDAR data and satellite classification. Hundreds of thousands of trees, and that's impossible to do without machine learning and training data. But we got a result there which got us a bit of confidence, and this is our next project. A particular issue that I ran into a lot here was Swedish training data, testing it. It's like you have all the English is great, but the Swedish was, yeah, there's no examples out there. Well, there is some, but not much. There's a lot of different parts to this project, but the one is most important, well, the one that I want to talk about most is the qualitative side. And that's where we're going to try these. We get like, what, 50,000 of these incidents reports a year, and that we're going to try and reclassify them or perform sentiment analysis or clustering based on different criteria. Also, the resources is quite good, because there's two of us that can work with the technical questions, but we're not responsible. It's for other people. The project leader is actually more social scientist. So we work on the technical side, and they work giving us the questions. What is it that they want us to answer? What is it that can create value? And I just want to point out that we're at a very early stage in this project. We've had one meeting so far, and the delivery is not due until late next year, just before planning, which will be carried out the year after. I hope this is readable. I'm not sure. But basically, we're here. The thought is, we can't really do requirements from the beginning, which we usually do with public sector projects. We can't do this big long document that we're going to do this and this and this, do a waterfall workflow methodology. We're thinking more agile and more learn by doing. But here we're thinking, okay, what is it that the organization wants? What can we do? What's possible? So we try to think broadly, test everything, we try to make sense of it. What is it actually? There's a lot of cool things with AI and NLP and that, but what is it that's actually going to do something? And how can we connect this to the organization? So it's kind of go out, talk to the organization, talk to different colleagues, find out what their problems are. And then the thought is we're going to narrow it down. Then we're going to once we have some sort of idea of what the organization wants, then we're going to test different methods, prototype, and then go out, do workshops, and eventually deliver something before the next planning for the different parts of the organization. So the thought is we want to provide reports which the organization will act on in the next year, in which they're going to dedicate resources to. Just to give an example, the main source, there's different sources. We go out and do surveys, like safety reports. So we go out, do you feel safe in this area? Go out and talk to people and write it down and get their views. But the main one is an app. So people put a point in the map. Maybe there's glass in the cycle lane. Maybe they don't feel safe. It's very, very wide. And then eventually it comes to the customer support center, who send it on to the person in the organization, and then the case gets handled. And there's a lot of problems with the data set. I've access to about 200,000 incidents, and it's strange. I don't understand. The labels have been changed from year to year, or sometimes things that should be viewpoints are recorded as wrong reporting, and error reporting is recorded as suggestions. And there's a lot of missing categories that are interesting to us. To pick up one issue that's important in Malmo, safety. That's one that we've been asked to prioritize, but there's no way we can extract safety from this. And it's like we're sitting on a lot of information. People take time to give in these long suggestions that can make the town better. But this is the only report we have. It's just like a count. We get one report per month. It's like there was 362 cases of graffiti. That's not really anything we can act on. And that's it. There's no broader reporting with this. So it's kind of some of the aims we have at this early stage. It's like the easy one is usually semantic analysis. So it's like, what are we doing right? What do people appreciate? What are we doing wrong? We're also trying to create what categories would be interesting to extract, like, for example, safety. And then it's also clustering. And there's different ways you can cluster. You can cluster on text similarity, geographical distance, time. The thought is that we can try and get where we have a lot of safety issues, then send it to the relevant part of the organization and get them to kind of act in a more kind of strategic or proactive way. And one part is in the councils in general, there's not many machine or deep learning or data science projects. So I think this is kind of a good way for us to learn by doing as well. So the thought is, when I started this, I thought there'd be a lot of other Swedish councils doing similar work. There's a lot of talk about AI and machine learning and that, but there's not so many projects. I think it's like within the next year, 2, 3, 4, when these will start up. So there's one other region, Västerbotten. They're doing kind of similar. It's more topic modeling there, but it was interesting to talk to them. And then it's also BERT, Transformers model. Yeah, that's good. and then creating the data set. We've created currently a very quick one based on Python and various ETL tools, and that just to throw together to test concepts. So it's multi-label classification that we do that. Yeah, that I tested over summer primarily. So it's kind of a binary classification. Is a suggestion, yes or no, positive, negative, safety, traffic, just to test the concept. And this was done very quickly. And the output we get is we run all our cases through it, and then we get some sort of probability here. So this one's 83% positive. This is 89% negative. Here's our positive map for all of 2020. Not so many. There's no clustering, there's no, I mean, if you're content with your town, if you're happy with things, you're not really going to report about it. You're not going to take your time and put your app that, thank you for this. The one cluster we got was people who were happy with the flower boxes on the bridge. So it's approximately for every 1 positive, 3 negative, which I thought it'd be a higher ratio. Here is safety concerns. So with the multi-labeling, you can have like high safety and then low traffic and extract those that relate to crime, darkness, too much vegetation, just don't feel safe. Kind of more of a feeling of this. And just by eyeballing it, there was kind of been a few clusters here and there for us to start with. And I said we've had one brief group meeting the whole year to start getting results on this. How we're thinking at the moment, classification, as I've spoken about. The big one, I think, is the clustering. How similar? Is there a group of text that is similar? Are they within the same geographic region? Try and find these trends. Try and find where people are saying similar things in an area. And I think that's what we're going to focus on most. Yeah, I mean, there's a few other things. The other interesting thing is I work with a lot of, as a geese engineer, I work with a lot of data. It's like we have about 1,000 between the different departments, different data sources. You got like traffic accidents, you got police reports, lighting, so we can combine it and see if things are pointing in the same direction. Because an issue here is who reports in these apps? Because the poorer areas of Malmo, they're underrepresented, while the richer areas, I mean, if we're to act purely on this, then we'd just be working with parking issues in the rich areas, which is the misallocation of resources. Yeah. So we're at the start. This might have been a bit premature, but I think it'd be interesting to come back in a year to show it could be boom or bust. If it's bust, then it's been an interesting experience. And I think that it's helped us, that we can, with methods, we can apply to other things as well. But I think there is a lot of, I think this can help us be a better organization responding to our citizens. So, yeah, let's stop there.
Questions?
Yeah, it's a really exciting project you're working on, and I would love to hear the next session in a half a year or a year or something.
Yeah.
That would be really interesting.
Mm-hmm.
Let's see what comes out of this.
Yeah, I'm very excited to see what geese can add here also extra. Yeah, I think that's
You talk about the data being poorly labeled.
Yes.
Do you plan on using unsupervised learning for clustering, or do you mainly want to work with labels that you have already?
We have two thoughts there. We're thinking kind of semi-supervised. And then we're also maybe dragging out a subset, so we take out all the ones that deal with, so we get all the ones that deal with safety issues, and then see if we can do some sort of unsupervised topic modeling there to put them in different places. Then maybe we can have weights. Like we have 5 years of data, so did this happen around the same time? And then the other weight is geographical distance, and try and find some sort of clustering between the three there to help point us in the right direction.
It was interesting what you said about the cultural aspects of applying AI in the public sector.
Yeah.
Could you talk a little bit more about sort of what cultural obstacles you can foresee, or what you think could be cultural issues around AI?
Yeah, organizational in the public sector.
Yeah.
Because I mean, it's kind of, I think there's a lot of focus on risk. It's conservative. So it's like you can talk about benefits, but then you might talk to upper management about there's unknowns here, there's uncertainties. It's like we don't have a clear project plan just yet. We have some sort of thing, we know something's there, but it's not enough. So it's been kind of, you need to be very careful with your language when talking to them.
Is it a project that will replace manual work, or is it something that will add extra value?
This is purely, I mean, manual work is one person does these reports every month.
Okay.
We're not extracting value from, it's like, it's an unused resource.
Okay, so it's more to create value, new value, not rationalize.
It's to augment our decision making. Where should we invest resources when it comes to safety issues? Or even something as simple as bins. Or we have a lot of ideas, but we're going to kind of narrow it down once we have more ideas in the organization.
I'll follow up on this the last question.
Yeah.
How do currently local authorities deal with these problems? How do they answer these questions? Where to invest resources? Where to fix some stuff? How is it done currently?
Yeah. Based on Malmstad and what I know, it's very much in the head of people. It's like someone who's worked a lot of time, they have a lot of experience. There's no smart database, which is kind of pointing towards this, based on this and this and this. I don't think there's much use for these type of things. Because there's so much information out there, but we're not really applying it to making the right decisions. Yeah.
I might be asking for the impossible here, but I'm thinking that this has the potential to do so much good for the city, and there's so much talent in Malmö and the Skåne region that can help you with this, to perform this work. And personally, I've worked a lot or some with the Linux Foundation, and their way of working is like work in the open. Everything is open source. You can join in some open meetings, things like that. And it would be really interesting for you to try out something like that within a project like this, where the data is open, the repositories are open, and you can contribute if you'd like. Because I believe it's not only me, but a lot of people that can do it and are willing to put in their spare time to making the place where they live a better place.
We organize a hackathon.
Yeah.
Yeah.
I'm gonna help you with that.
Yeah, I know. I'm very much kind of putting this all out in GitHub methodology, training the rest of it.
Yeah.
But we need to get clearance from our data Gdpr.
Yeah.
But I mean, if we get clearance from the data protection person, then I know that's the obstacle.
It must be like, it doesn't sound like very sensitive data, especially like street data. It's there already, people actually see the data, but it's just being logged.
There were names in the data.
Yes.
That's just
people put in their names, put in their. I mean, Redix can take care of a lot.
Yeah. You can anonymize, data automatically.
Yeah, there's name identity recognition. I haven't had time to test that. And then I need to talk, but if I get permission there, then definitely give them. Because I would like to talk to other communities.
Yeah.
Or we're thinking of contacting universities, because I think there's an interesting thesis here as well. We maybe get students in to help us. So I'm very open to this, if possible. Yeah.
Have you thought about having social media, like people tweeting, like Malmstad, and there's certain hashtags reporting these kind of issues as well? Or is it only through this web form?
We haven't decided that yet, but I'm able we have an extraction tool where I can collect in everything that's typed at Malmstad. So that's a maybe.
Like if you have a specific hashtag, so people, instead of going through this web form, because I didn't know about this tool, but I would imagine if you could, you can actually submit it through social media like Instagram, Twitter, people might be adding more of these kind of reports.
I think so. I think eventually we might come to that, but at the moment it's kind of like we have this data that we're not using, so let's get a result there. Yeah, but I mean that's another source. And, I would not exclude that. It's just we haven't talked about it yet.
I think you also have the issue with social media that you will give the data to the social media communities, and that is not the most popular thing to do in this context, because that's why they built the app, because then they can control the data source. So I think there is also some questions that need to be answered before you do that.
But they are active on Twitter, Facebook, and stuff.
So I actually did my PhD on machine learning for issue management, but in a software development context. Data management, basically trying to automate try to provide decision support for developers. And I think I have plenty of experience to share it, so we should be top. So don't go home too early.
No, we'll definitely chat at the break. Yeah. I mean,
and students, yes, for sure, it's a good topic for students.
Yes, I really think so.
All right, more time to speak to each other when it's pizza time, because then we have next speaker.
All right. Now my presentation will be a bit more showing code, maybe even attempting live coding. Not sure yet. I'm not, scratch this. For those of you that have been at LTH and had him. So my name is Isabella. I'm working at Noraxon, and I'm also now a Barrel coordinator. So at Noraxon, we have something that we call Kaizen, which is basically that we get some time each week that we can spend on either fun projects or, like super serious, let's get down to learning. So this all started when Melina sent me some pictures, and I'm gonna show you those pictures in a while. And I was laughing at them, and I thought, oh, those pictures are amazing. And then what would happen if I tried to classify them? Because, after all, I am a data scientist. So I decided, this is like the picture, but I have blurred it so you won't see what it is until I actually open the code and run it. So I decided to actually use some pre-trained models. I tested a couple of different ones. Those of you that are not familiar with the pre-trained model concept, it's basically huge models. They are trained on lots of data. For example, we have the VBG16. It's trained on 1.2 million images, and it can classify 1,000 different things. So anything from like cars to mugs or animals. So let me show you what I did. Let me just close that up. Perfect. So this one is called cat mashups. So yes, there were cats involved. And let's hope that the code actually compiles. So, I saved all these images. Also, I found the Instagram where these images are created. And of course, I was very polite. I asked for permission to actually download them and use them for this. And so I did. I saved 20 images, and then I added a last one for, testing purposes. You can see here that we have images that are 299, 299, and 3. So that's width, height, and then we have 3 channels because it's color images. So I will show you the images. Hopefully they will look fine. And I mean, seriously, who wouldn't think like, okay, let's try to classify this? I mean, it's 20 of them. I can just go on and on and on. Yeah. That one is my favorite because it looks like my cat. I think, Melina, this one, the goldfish, is your favorite, right? Yeah. And I tried a couple of different models. it's kind of hard to decide which model is best. Like, is it better if it finds a cat face, or is it better if it actually like finds this as some type of owl? It's hard to tell. So of course, I also had to add at the end a picture of a normal cat, just to make sure that the models actually work on normal cats. So I started with actually trying the VGG16 model. It didn't really work that well. I will tell you what it classified. And this is a pretty large model. Actually, it was the only model that wasn't part of the image that I had on my PowerPoint slides. So this is the model. I mean, you see, it's kind of deep. Because I thought, well, you know, the bigger the better. Actually, not really, but yeah. So we did some predictions on these images. This is essentially that code. Yes, of course, I knew it. It blew up. Actually, I'm not even sure what this error is. Well, luckily I have backup. So I actually saved how these images were predicted, so I can show you anyways. So starting from the top, 45% ostrich. I mean, I can't really see it. I didn't know ostriches had ears. We have this one which totally missed the target. Like, it didn't even get avocado. Granny Smith, cucumber, and zucchini. Cabbage butterfly. I mean, I can see why. I'm not sure I agree. Fox squirrel. Well, you know, we have some that are just. It's kind of correct, you know. It's just not really correct. This one is my favorite. It completely missed the target. And I actually tried on the original image as well, and it still didn't get it. So what I actually was looking for, I will show you the heat maps that I made, and it's activating a lot around here because it turns out that this fin looks like the wings of a hummingbird. So that's why. And well, you know, this just goes on. This one was actually quite interesting because I thought that cheetah, okay, so obviously it doesn't get giraffe, so maybe it saw like these types of patterns, it saw some type of cat face, and it just thought, okay, cheetah. Well, you know, goldfish. You know, I go on, and this one. All right. So this one was also interesting because I don't even know what a flatworm is. And I had to image Google it. And it turns out that it's some type of like sea cucumber type of thing that lives at the bottom of the ocean. And it kind of looks like this part right here. So that was why. So, I mean, yeah, how do we know what the model has looked at when it was classifying? Like, did it even look at the image, like the faces? I'm not even sure. Let me just close this down. Okay, so obviously I had to make heat maps. So for example, this was a heat map of the ostrich. So I mean, it saw the ears, but it still made it ostrich. I don't really know what happened. And some of these heat maps, it completely misses the face. Like it's actively not looking at the face. So for clarification, the heat maps is basically what the model is looking at when it's classifying. Obviously not the cat face. And yes, that was, I also made GIFs because GIFs are fun. So this is essentially the heat maps from all the layers in the VGG16 model. So we can kind of see how the CNN shifts focus. So it starts with all the details in the image, and then it moves on and looks at bigger and bigger parts of the image. And finally, it classifies. So that was my first project. And I saw it basically, you know, as a reminder of the importance of data quality. Because, I mean, you can train a model on this and that much perfect data that doesn't even exist. But if you don't make sure that the data that you actually send in afterwards is good, then some things will happen. You won't know. You will get predictions, and they may be completely inaccurate. Like, for example, Melina works with anti-money laundering at Danske Bank with data quality. So this is so important, because if you don't check the data quality, you don't know what's going to come out at the other end, because the model isn't prepared for that. So that was my first Kaizen project. My second Kaizen project, actually this time I don't have the code because it's on my other computer. But it was that I found the Selma Lagerlöf text file on my computer, and I thought, oh, this is fun. So I did a small LSTM project, basically, and this will only make sense for you that actually speak Swedish, unfortunately. So I trained an LSTM model, and then I took like a seed from the Selma Lagerlöf book, sent it into my LSTM model, and looked at the output, so the generated text. So the input was, det har bara bestånd för några år, men när ni säger mig att i Östergötland alltid ska finnas bönder. So we can guess that the last word is bönder, but I had to cut off the C because it was specific in length. So my model predicted bönder och stränderna, och sträckte ut sig och stack in i stranden och såg sig om och se en stor stark. Och stora starka stranden och stod och stack in i stora stenen som hade stannat i stora stenen. So, you know, there's a lot of things that are big in Östergötland. Maybe you have to actually go there to see all the greatness. For those of you that don't speak Swedish, this doesn't make any sense. I mean, it's words. It's basically grammatically correct. But I trained a model only on one book. Like, that was 186 kilobytes of data. That's nothing. And of course, Selma Lagerlöf, she had a better continuation. It made more sense, essentially. Also, fun for you that don't know, but there's actually books written by AI. It's called Books by AI. And also, the images of the books are created by GONS. No. Oh, yeah. I don't have to. Oh, yeah. I think these are also based on LSTM models. These are from, I think, 2018 or something. So it doesn't make a lot of sense when you read it. Sarah Ford finds herself provided with no reader in the greatest experience of London to his trademark fiction. I mean, it's words. I'm not sure reading an entire book of this is satisfying, but you can. And of course, I've been thinking, like, okay, so this is an LSTM model, and also, as Ray was mentioning, like, it's hard to find models that are good in Swedish. And have you heard about GPT-3? Yes. Like, yeah. So I was thinking, you want to do like a GPT-3, right? Every data scientist's dream. So like that's my next idea, because so this is GPT-3. For those of you that don't know, it's a huge transformer model that was released by OpenAI in like June this year. It creates it generates very realistic text in English, and this is the technology behind it. I won't go into that because we don't have time. But I found something called Hugging Face Transformers. Has anyone heard of that? So I will show you. And I also found a Swedish text dataset that was 25 gigabytes. I mean, that's pretty much, especially when it comes to Swedish. So let me show you. This is Hugging Face Transformers. So they have essentially created like a package where you can train or fine-tune transformer models. They have, you can do summary, you can do training and fine-tuning, model sharing, uploading, tokenizer, blah, 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 everything. And these are the models. This one is my favorite, name-wise. It's a French, it's an English to French model translator. And so I was thinking, okay, so the only GPT model they have here is the GPT-2. And I thought, so I found 25 gigabytes of data. They have a lot of data on this OSCAR corpus. And I want to train my own transformer model. And I'm essentially using today to ask if someone here has been training a transformer model on any type of language, and please share how you did, because I have run into some problems basically on Google Colab. And yeah, that was basically everything from me. I hope you had fun. Questions? Oh yeah, questions. Yes, please.
How did you extract the heat map from the neural activation?
Oh, okay. I can show you. So, first of all, there's a book called Deep Learning with Julien. Have you heard of it?
No.
Okay. So he has. So this is an author, and he has written a book about deep learning with Keras. And he also has, so in this book, there's a lot of code. I know my friend Jakob over here knows about it. And he also has his GitHub. And this is where I found the code to the heat maps. So essentially what you do is that you take the gradients out from the last convolution layer, if you're looking at the last convolution layer. And then you do math magic, and then you get the heat map. So essentially, you just copy paste his code.
Long story short.
Yes. Yes.
Outside of text generation, what else are you hoping to do with the Swedish language?
Not really sure. I mean, Oskar and I are working here at Helsingborg, and so the project that we are looking at right now is, well, we actually have two projects. So the first one is dialogue training for newcomers, so those that want to learn more Swedish, and that they can have some sort of natural-ish conversation with a bot behind a website. So like an advanced chatbot, but you're talking to it and it's talking to you back. And the second part is basically the same idea, but with the goal of interview training instead. So ideally, something that Oskar and I have been talking about the last couple of days is also, now we're just thinking big, but creating a data set and eventually making an automated speech recognition model in Swedish. So essentially, just setting up a website where people can log in themselves, and they can put we want some metadata about what we have in the data set. So maybe age and gender and where they're from. And then they will record a couple of sentences, type down what they said, and then we could use that data to create a model that actually understands all types of different accents that we have in Swedish. So that's just, brainstorming basically, but that's it, yeah. Anything else? So if you're wondering about sorry?
I'm so curious about the cat.
So
what about the cat?
What
Is it
about
a
the
cat?
cat? So let me show you the Instagram account, because it's a person sitting doing this. You can also for $5 you can send an image of your cat and then the animal that you want the cat's face in, and this person will do that for you. So you can make money in all types of ways. So I mean, you have.
So I mean, the real cat. How
Oh yes,
how
the
did
real
your
cat.
algorithm
Sorry, yes.
assess?
Let me show you.
Yeah.
Let's see with predictions. No, it's not seeing. So I can tell you anyways. So the real cat was predicted. So I picked out the top 3 predictions. The first one was tabby, which is essentially a cat with stripes. And the second one was Egyptian cat, still a cat. And the third one was some other type of cat animal, still legit. So it actually worked very well for that image. I haven't tried any more though. But I mean, these models are not perfect. So essentially the creature, yeah.
Yeah, it was the only cat in the cat animals.
Yeah, exactly. So, I mean, if my code would have worked, you would have seen it. But yeah, that's what happens when you try to live code. Essentially, learn from my mistake.
What did the heat map say on the real cat?
The heat map, actually, so the last, so the cat was looking, you know, it was kind of like at an angle. So the heat map was mostly focused here, like in the last layer. I didn't make a GIF for this one because I like threw it in at the end because I was like, oh wait, I probably should check this with a real cat to make sure. So it actually activated around here and a bit on the tongue for the last layer. Not what I thought, but okay. Sometimes, yeah. Exactly.
Yeah.
You would think it would be like around here. Yeah. Yeah. This is like a fun project, you know. You just see something and you're like, actually, what would happen if?
What's your next? What would happen if project?
I don't know, because they like they just pop up, you know, when you see something fun. I think like what I'm most interested in right now is actually exploring this, well, both this transformer model. I want to like generate like really good Swedish text about, you know, gibberish, but still, you know, maybe actually make a transformer model and then like fine tune it on some type of like specific text, like the Selma Lagerlöf books, and then like create something more elaborate, maybe like a longer story, not just like 500 characters.
Create a gun.
Oh yeah, that's right. For the office, we want to have like, you know, more paintings on the walls. So what about gun art? You know, so for those of you that don't know, guns are they create deep fakes, if you've heard of them. Like that's one application. It's essentially like two networks competing with each other, and then the one is like one of them is trying to fool the other one, and it will create fake images. So we want to create gun art because you can like train it to create art. So like if you would train a network like that on like maybe all Van Gogh images, it would create Van Gogh like art. So that's like our next Kaizen project that we will do internally. Yeah.
All right. So, Sorella, thank you. Now before we start, but I'm thinking, how do we? I think it has already arrived, but I think we should go for a fifth one before pizza. Sure. So we can all eat a pizza. It's always fun. Always, yeah.
All right, so I'm here today to talk about our AI market survey, which we have performed through AIQ Meta Testbed, which is a pre-study and a project that me and Marcus Borg have been working on together with Joshua Bromson. So I'm a student at Lund University, and this was something we performed during the summer and a bit during this fall. So here are some of the companies or the organizations that helped us. And just a quick note on the AIQ Meta Testbed for those who weren't here the last time Marcus was here. This is basically a testbed for testing AI testing, or an AI meta testbed. And what we do is cherry pick research that we find promising within AI testing. And then we try to validate this and evaluate which methods are the most promising when it comes to testing machine learning or AI applications. Also do courses in education. And then we do some PhD supervision and collaboration. And we're currently working on in-house AI testing. So the background for this survey is of course, AI has been around for a very long time, but it's booming currently. And AI market is estimated to grow 54%, or was estimated to grow 54% in 2019. But however, we find no good mapping of the current state of AI in the Öresundregion. And just a way to show the trend, this is the Google Ngram viewer, looking for mentions in literature worldwide. So we here can see a peak towards the 90s, and now we're coming back. AI is back, but also machine learning is coming at a steady pace. You can also check the Google Trends for AI and machine learning. Here we find the opposite, where machine learning is still less popular for the global crowd. But continuing on to the survey, we have some inherent challenges of AI market surveys. One of these is, what is AI? Because there's currently no real consensus on the definition. And to find AI companies, really have to define what an AI company is. Another problem is that there's a lot of fuss and buzz in the AI industry. People who are actually employing AI in their companies and not just talking about it, because you will find a lot of companies talking very enthusiastically about AI, but that haven't got any projects that they haven't started yet. And then there are some AI companies that actually avoid using the term AI to avoid the fuss and buzz. They prefer talking about data science or machine learning or specific models that they use. And this also makes it a bit hard to find them. But moving on, here are two inclusion criteria. So the first one is that the company must present current AI activity through products, projects, or divisions. And examples or pieces of evidence could be news articles, web pages, white papers, product description, blog posts, or organizational charts. The second one, as we were focusing on the Öresundregion, is that at least some part of the AI activity must be in the Öresundregion. Also important to state is that the goal of this survey was not to evaluate the business potential of the individual companies, but rather to get a snapshot of the current technology adoption. So this was the geographic scope, and later on the main focus was on Helsingborg, Lund, Malmö, and Copenhagen. The data collection was mainly done through web search, direct contact with AI companies, and also with the help of local tech hubs. So let's look at the AI trends. So from all the companies that we extracted, we also extracted from Ratsit the founding date. And we can see in Sweden that most of the companies are quite expectedly towards the end of or towards the 21st century. And then we have quite a lot of large companies that are spotted throughout the 1900s. Looking at Denmark, we see a similar trend. Not as many companies were found in Denmark or Copenhagen, but the region was also larger in Sweden. Continuing on to financial data, we looked at the Swedish companies, and here you can see quite interesting data. So we can see that most of the companies have a profit distribution or a profit that is around zero. Looking at the average profit, we see that a lot of companies are losing money. However, the averages are a bit misleading, as there are some really big players who lose a lot of money and some other big players who are currently earning a lot of money. So it's better to look at the median profit, which is zero. Moving on. Moving on to the turnover. We can see similar patterns here. The median turnover, if we start with median turnover, is about 16 million Swedish crowns. Looking at the average turnover, same thing here. Actually, this graph doesn't end here, it ends way over there, with some really big companies having huge turnovers. But in turn, these companies might be working with completely different things, but have a small AI project or a small concept. And that also makes them a part of this survey. So it might not be correct to classify them as AI companies or companies only working with AI. But this is the main distribution. So looking at the active locations, here we can see the Öresundregion. We have a lead from Copenhagen, which one might expect as it's the capital city. Then we have a strong second position from Lund, which have a strong university and the university research and also all the activity around Lund as a city. Then we have Malmö, also a large city, which one might expect to see a lot of activity. Then we have Helsingborg at 5%, and then we have at 2% a bunch of different smaller places where they also have AI activity. So here we also extract the different divisions. And here we can see a trend that is not very surprising, but we have computer programming, consultancy, and related activities with 54 occurrences in the data set. But then we also can see that it is spreading to the other sectors as well. We can see wholesale trade, we can see publishing activities, and also electricity, gas, steam, and air conditioning supply. So there's a quite good spread of different sectors where AI is currently being applied. So in total, we found 130 AI companies in Sweden and 80 AI companies in Denmark. And all of this data and the entire report will be available at the table over here. So you're feel free to take one home. Then, of course, you can also download the data sets as CSV files if you're curious more about the financial data or looking at more in depth which companies were selected. So that's basically our survey. And I would also like to say that we're currently hiring. And if you want to know more about that, you can talk to Marcus during the break. And that was it. Thank you. I suppose everyone's feeling pizza right now.
Always some questions.
What about finance for this sector? Is it easy to get financial support?
If the financial companies are
within the AI
well represented?
Yes.
Yes. If you look at the different sectors, you can see that the financial sector is strong. Of course, because there's a lot of money to make if you successfully employ AI. But then a lot of the companies also have smaller projects. So looking at bigger banks or bigger financial
you misunderstood. I meant founding startups or companies working within the AI sector. Is it easy to find the financial money support?
That we haven't looked into. I'm not sure. Like with the AI buzz, I suppose a lot of people are throwing money at AI startups. So I think, especially also looking at Vinnova, again, they have a lot of AI initiatives. So I think if you have an AI startup, it will be pretty easy to find money if you have the right.
Have you made any assumptions or definitions about AI when doing this survey?
No, not really, because we to explain, we actually took the companies on their word. So if they say that they're working with AI or machine learning, that's the way we classify the companies. So we didn't really see any intrinsic value. As using AI doesn't have to be good or bad. It's just a fact, a technique. So we didn't really question whether they were really using AI or what their machine learning models were.
But could there then be companies that one might say work with AI, but they themselves wouldn't well define it as such? Like statistical methods that one might actually put into the AI.
Yeah. Sure, yeah. And as I said, a lot of companies prefer to talk about using machine learning rather than AI. And then where do you draw the line with machine learning? Is simple linear regression machine learning, or is it how advanced it does it have to be machine learning? So there we have the same questions as with AI, where to draw the line. But no, we didn't really make any assumptions of what was really in the companies or what they were doing. All right. Thank you very much.
All right. So there's some pizza, but before we actually have 2 questions on YouTube because we are being sent out, and I would like us to actually. I'm going to state them here, and so I believe the first one is to Erik. Again, and it's from Balash. So here, do you see it as well?
No.
So what is the greatest barrier to using generative AI more broadly to overcome privacy issues? What is the greatest barrier to using parental AI more broadly to overcome privacy issues?
I think in general sense, it's always upper management, as you said, right? It's like getting the managers to understand the value of the technology and explain it to them in their language. That's the barrier for any technology and also the AI tech.
Yeah. But there are some, leaders actually accept the fact that they need to kaizen themselves, learn new things. And there are plenty of courses both online, but also different companies offering those education. All right, there was another one as well for you. I'm sorry, Eric. Right, Eric. Open source is surely not for every sector start with POPs. Okay. Well, this is
a comment, okay.
Yeah. And then we have, I believe this must be for Ray. What technique are you using for clustering tasks?
Clustering?
Yeah.
I haven't really looked at it too much.
Yeah.
But I borrowed a model from Västerbotten,
yeah,
which does some topic modeling in Swedish now, so I'd be happy to share with whoever that person is.
All right. It's here on YouTube, so I'm welcome to see. Yeah.
Yeah.
All right. So pizza time, 10 minutes something, speak to each other, but then maybe, we cannot work after all the great preachings because we have, how many? 3 more very interesting ones. Yeah, all from semiconductor parts to cybersecurity and food waste with Joachim. All right.
Jag har faktiskt en slide på inom AI och industri.
Ja, det är så du känner.
Alltså jag kör den på.
Vill du bara sitta och ställa dig med dig i bordet ett ögonblick och prata lite? Prata som om det höll.
Hejsan, jag kan då berätta för er att jag...
Tack.
Du är naturlig begåvning.
Verkligen.
Jag kan vara en disk.
Jag ska äta på ditt element.
situations that use public data like Instagram to spot different places and to get extra quality feedback. Because like people tend to make some lists of the places they like. Yeah, and it's just analyzed Instagram how and it's and it might be used for the ways clients and so to get more information, not just this place on the site. Yeah. Student city, and like the architecture is super private. Yeah, so in I don't live a lot. Yeah, it's just going the other way around. Because what makes it
What an awesome presentation you did. I enjoyed every second. It was so good. Thank you.
Thank you.
Thank you for bringing that.
Ja, det fick du också.
Vad fan? First, not that much. There's one in Finland that is 6 years. And it goes back to the Swedish language. There's a lot of nice teachers. Taking this zero shot to your I want to see that it's moving so fast. It's like you read a text. Yeah, but it feels like it's just like sped up. It's gone from being kind of like it's gone mainstream this year. I don't know.
Det är så? Okay. Yes.
Får jag bara detta var på förut för de minuterna som är kvar. Jag måste springa på toa och sen ska jag köra efter. Exakt. Ja.
Det ser bra ut, va?
Ja, absolut. Höga tandstäckor så är det inga bra.
Jag tyckte...
Joakim, som hade ringt till jag ska jag kör den här bara.
Ja, exakt. Också
nummer 4 där. Är de liknande?
Ja, lite så, ja.
Då ger vi en varm applåd till Joakim som ska prata om matsvinn.
And we're back to Swedish.
Yeah, I'm back.
I love that how you bounce back to Sweden. It's like you can't help yourself.
Yeah, I work in Denmark, so I have 3 languages running through my head every day.
Still confused, but at a higher level.
Yeah.
Lovely.
Joakim,
Yes.
can I ask one question? I took some pictures to maybe we will put some up on Hobby Works Instagram account.
Yes.
Is there anybody that doesn't feel comfortable with that? can you let me know, and then I can make sure that that picture doesn't make its way up into the abyss. Okay, thank you.
Okay.
Thank you.
And if we should go by the Schrems 2 judgment, then not anything should be able to be put on Instagram right now. It's a horrible situation. Basically, everyone is in breach right now, just so you know. Okay, so let's talk about matsvinn. That's food waste in Swedish. And I think we can all recognize this image. And if you take what happens in your home and you funnel it up to the whole world, then you're going to realize that food waste it's a real problem. And I'm going to give you some insights on that. But first, I have to excuse myself because I'm not a hacker anymore. I used to be. Way back in 1993, I was really a hacker. It was back in the days where we had no frameworks, we had no tool libraries and such. It was really hard to be a hacker back then. So I'm actually very envious at the situation today. And sometimes when I feel like, really to indulge myself and have fun, I try to do some coding today, but it's not for public use. It's just for me. But I'm still a geek, right? I'm still a geek, and I love everything that we talk about here. And since some while back, since April, I'm the CEO of a company called Get.ai. And we want to apply AI as a broad term in everything that can make the world a better place. So why not start here? Why not start with food waste and what food waste actually means? It is a matter of sustainability. It's one of the sustainability development goals that the United Nations has framed. It's the 12.3 that you can look into. It is a matter of economy because all the food that we throw away is like throwing away money. And in this case, it's also a matter of the well-being of students because we have focused on food waste in the schools. And everything that is getting thrown away isn't eaten, which means that the kids don't get the energy that they need to sustain the full day. And to kind of frame this into some numbers, I mean, it's absolutely devastating how much food we waste every year. And if food waste as an environmental crook was a country, it would be the third largest sustainability crook in the world. That's how much food we throw away every day. And then if we boil this down to Swedish schools, it's 62 tons of food every day that is just wasted. So the city of Helsingborg, of course, decided to do something about this. And way back in 2017, they started a project called Smart Mathållning. And the aim was to actually reduce the food waste to half, cut it by 50%. And to do this, you need someone with AI without the A. So this is intelligence on a picture. Cecilia Larsson, who has done this in Helsingborg, has done an absolutely amazing job. And the first thing they realized was that we need to measure what's going on here. So they started to measure how much food was thrown away from the kitchen, how much food was thrown away from the servings that was plated that never got distributed, and how much food was thrown away from the plates of the kids eating. And I mean, it's amazing what they achieved in 2 years. They actually already managed to cut food waste basically by half in the Swedish schools. But when you get that taste of something, when you see the possibility of doing something, of course you want more. So Cecilia came to us and she said, well, I can't nudge people any further. I've done what I humanly can do. Now it's time for the machines to take over. And I think you can realize that if we serve something like 20,000 meals every day in the Swedish schools, and we measure at 3 points in every kitchen, there's a shitload of data available for us to try and make sense of where does this food go. So we decided to bring on the machines, do something with AI here, and we're not the first. I mean, we didn't invent the idea to try and cure food waste by AI. McKinsey did a report where they said that we could actually save $127 billion in not throwing away the food. So we're not the first, but I think we're the best. So looking at what we actually did then, I love this kind of boilerplate of all the problems we might have when we work with AI in public sector. And of course, the data we have is also inconsistently labeled. We don't put pressure on the chefs and the people working in the kitchens to label their food in a specific way. So sometimes it's pasta, another time it's spaghetti. Sometimes it's bolognese, and other times it's Swedish färs sauce. So there's a lot of inconsistency here. There's a lot of kind of rubbish in the data. The two things we really had an upper hand in, and that's one of the reasons why we selected this problem. Bias is not really a problem when we try to determine food waste. I mean, the banana doesn't get offended if it's classified as a potato. It might be a huge problem when we talk about data consistency, but it's not bias per se, and especially it's not the problematic version of bias. And also GDPR, the same thing. The potato has no idea at all about what we do with its data, and it really doesn't care. So this is something that we think it's kind of a low-hanging fruit. It's something that is safe and possible to work with, and it's also positive to work with because everyone agrees that we need to throw away less food. So what we did then, I listened to this presentation, and I love what you were doing in Malmö here. But I still get frustrated when I hear that we aim for something to happen the next year, to happen in 6 months and so forth. And even in terms of public sector development, that's fast, right? But I get frustrated because I want to look at what we can launch on Monday. What can we do in a week? What can we do in a month? So we decided to have a really speedy process here. So the first thing was to get that intelligence, to get Cecilia up there, to get her into the room and have her frame the problem as she sees it. What do we need to fix? And what possibilities do we have to fix this? What are the data we can work with? And instantly we got a brief from Cecilia that was world class. It should be like a template for a brief that you get from someone who has a need where data can be the solution. It was absolutely amazing. We were instantly empowered in this group to actually start doing things. No processes of decision making, no clearances, no compliance, none of that. Then we decided that, it looks like something could be done here. We did pretty much a POC over just a day, and we realized that this data is actually possible to build with. And then we decided to move very, very rapidly into a minimal viable product that we could actually deliver to the kitchens and see if it could work. So basically, this was a 3-week process from the initial get-go to launching. It would have been a 3-week project if the lead developer didn't decide to have a child in the middle of everything. And we know how that works in Sweden, right? So we basically lost the summer there. Anyway, in actual working time, it was about 3 weeks. And what we did achieve then, I'm going to show it live because that's how we work. The first thing to do was to actually try and classify the data. And please don't ask me about the models and the tools used here. I only know that it works, right? But there was a classification taking place, trying to understand, if we look down here, trying to understand where did we use bulgur, where did we use fish, where did we use potatoes, and so forth, to try and understand what are the categories that we're working with here and how can we actually try to make sense out of them. Then we did some visualizations, of course, so we could instantly see the progress that we make from year to year. We have a collective view over here where they can start doing some digging, and they can compare their unit with other units of the same kind. They can compare their unit with the average of all units in Helsingborg and so forth, and they can dig really deep into it, and we can see how the waste varies over days and so forth. And it's just visualizations of the classified data. We took that, of course, even further, so we could look into ingredients and see how different ingredients performs. And one of the things that we aim to do here is to add CO2 data to this, because in Sweden, of course, a potato that is wasted is not as CO2 intensive and not as harmful in a sustainability matter as pasta thrown away, for instance, or noodles or rice or whatever. So we're going to add CO2 data to this, of course. The different units can compete with each other in different ways, and we can see weekdays, and basically anything that you can do with visualization of the data we can do. But the really cool thing is probably when we move into the miljööversikt, and we can see how we, for instance, can take kryddig kolgryta, and we can explore kryddig kolgryta, and we can see that it's also the same thing as Italian kolgryta. Sausage stew, it's the same thing. It's the classification that's going on beneath the hood here is pretty much amazing. But then we took it one step further. So we actually added predictions as well. So we are in week 42 now, right? We can take a look at the menu for week 43, and we can make a prediction of how that menu is going to perform from a food waste perspective. And once you get this tool in the hands of the chef, they can start to, of course, change the menu. They can in the next version here, they're probably going to have a tool where they can actually drag and drop the menus and see what happens if I move this Italian sausage stew from Tuesday to Thursday. What's going to be the effect on the food waste that we generate? We can look at long-term learnings here. So the first time you serve a new dish, it's going to be thrown away like crazy. The second time, there's going to be a higher level of acceptance. The fourth time you serve that dish, it might even be one of the kids' favorites. And if we learn by looking at the data in here and make those graphs and make that understanding out of food waste, I'm absolutely convinced that we can actually, make a real change here. So that's what we did, and it's all based on existing data. Now, another thing that we're of course going to do here is to add more data sets. So we can, for instance, bring in weather data and see, does that change anything? Do people throw away more pasta on a rainy day than they do on a sunny day? We can, of course, integrate schedule data to see if it affects a dish in a different way, if it's served before a free hour or so forth. We can bring in all kinds of data, health data, of course, and we're looking at ways to match this up with flow predictions to see how many people are standing in the queue outside the dining room, and if that changes things. And it's just a beginning, right? It's one little seed to see what we could do with existing data and how we can move that forward. So that's the thing, right? And it's available for everyone to move into. When you get the presentation afterwards, you're going to have a link so you can actually dig into the data and see what's going on. Business model-wise, we felt very convinced that this was something that just needed to be done, and then we're going to see how we can make some kind of money with it. We're going to deliver it, of course, as an open source model, so everyone can just download it and play with it for free. And if a municipality in Sweden wants to do that, then that's fine. We're also going to offer it as a service, of course, where our intention is that everyone who uploads their data into this system and starts using it is also going to contribute to the data set itself, and more data is, of course, good. We're going to implement over time self-learning mechanisms, so we get learnings back from the system into the data that we visualize. But it's just like this amazing beginning of something that we think is going to be really, really cool. And the reason I'm here today is, of course, to connect to this beautiful community and reach out a hand and say, if you want to contribute to this in whatever way it might be, please give us a holler, and I promise we hit the ball. Thank you so much. Yes?
Have you had other municipalities already reach out expressing interest in this type of analysis?
Not directly. There is an organization within Helsingborg called Familjen Helsingborg with all the smaller municipalities around us, and they have gotten a sneak peek of it. But we haven't really started talking about this. This is the second time that we show what we've done. Not yet. But I'm sure they will. I'm totally confident.
I'm sure as well. I think it's a great idea.
Yeah.
How do you handle changes in trends and things? Because there are a lot of different trends, and you vegetarian and different types of food, and specifically in the school, I think that might change quite rapidly sometimes.
We had a conversation about that, Cecilia, didn't we? How do we handle that kind of change?
Good question. I think we will try to. Actually, I don't know. Actually, it's tricky. We're just in kind of a phase that we're trying to learn as much as we can and what we can do with it. So, yeah.
I think the key here is probably that the people working in those school kitchens, they kind of know it, right? They kind of can sense that something is going on in the way the kids respond to what is served and so forth. But what we can do here now is that we can actually move it into kind of a structured thinking, and we can start looking for new trends, and we can start seeing answers to questions that we probably didn't even know that we should ask, right? So I just think that visualization here is pretty much the key. This is a tool to get people better informed and thereby make better decisions.
Is the dataset open?
The dataset will be open, I hope, right, Cecilia? Yeah. So right now there is this thing that there's a lot of big organizations delivering systems for the school kitchens in terms of groceries and menus and all that kind of stuff. And those organizations haven't really embraced AI and data yet, right? So it's kind of a struggle to get the data out of the system, to process it, to clean it up, to make sense out of it. But our intention is definitely to open this data up. And our intention is also to push others to open up their data. So for instance, within RISE, the Research Institute of Sweden, there is this big database of carbon dioxide footprint of every ingredients basically that you can put in food. But that data is only available for sale, right? So you have to pay to get it. And in our day and time of environmental engagement and sustainability issues, I think that should definitely be something that we find another funding model for, so we can throw that data out for everyone to use.
So, what was the biggest reason for food waste? Was it plainly that the students didn't like the food, or was it like poor planning from the cooks? That they sort of misjudged, like a school was out of for an excursion?
So, based on what we've done now, I don't have any new answers to you, but there's probably some old answers. And I think the main thing that they did to cut food waste by half was to just start measuring it, to put a number on it and make it visible how much we throw away. And that engages people in a process. And when that process has started, it's about communication, right? So why do you throw away less food than we do, right? And you can have a conversation, you can learn from others' experience and so forth. So. But I'm sure that there are so many findings buried in this data that we're going to untap.
But I'm thinking this could be useful for the restaurants as well. I mean, and then all the other, big corporates will actually have their own canteens and so on. So it's not only to the schools.
Oh, yeah.
Nursing homes, elderly homes.
Yeah, of course. It's a huge market, right? And of course, there are companies trying to tap into that market. So in hospitality, for instance, there is a company called Winov, I think, that is pretty big. But they sell a whole system with scales, and there's AI to try and determine what you actually throw in the waste bin and so forth. And from my perspective, looking at them and showing their systems to the public sector, it's just like, it's too complicated, it's too much, and more than anything, it's too expensive. So this is kind of a middle ground where we're trying to do something that is actually doable with an economic model that can fit the school. But of course, we would be really happy to sell this to the flight company.
But I'm also thinking about data quality as well. If you have like a meal and then you just throw, you have to separate things to actually have a proper measurements on how much potato is thrown, how much meat is thrown, how much vegetables. Yeah. IKEA is doing that, I know, but most, I don't know, maybe schools that haven't been to any school for a while, but...
Really not, and that is, again, that's the problem with the data quality that we have chosen to so far ignore. It's also an issue of a whole potato is lighter than mashed potato, and we don't differentiate between that right now. We just feel that if we have to start somewhere, right? And if we don't raise the barriers, and if we don't put too much friction into what they're already doing in the kitchen, the possibility of them being, agreeable with a system like this is probably higher. So getting the users to use it, that is one of our main tasks.
Yeah, I think that's actually something that you're understating in the success of this story. It's not the fact that you can do the analysis on the data, but actually that you can get laymen or the personnel, the chefs or the cooks in the kitchens to sort of utilize the tool to make a change. And I think that's the general challenge for AI and employing AI in real world cases, that you get normal people, so to speak, to use it, right?
And even
how do you do
more,
that, right?
Yeah, and even more, one of my wet dreams here is to actually have the kids play with this data. If we could, somehow build like a teachable machine or something that we could give to the schools where they could play with this data and model on it and try to make their own. Yeah, I mean, how amazing wouldn't that be? And what kind of level of awareness wouldn't that raise within the kids if they can actually play with this data themselves?
You need some nutrition thresholds then.
It's an uphill battle. It's a constant struggle and an uphill battle. I think there was something more there.
It's the practical question how the data was gathered with such a high resolution. You had separated like carbs from meat and such. Did the kids toss the food on separate scales depending on category, or?
No. At this point, we're only looking at the menu, right? So we try to determine from a menu that says spaghetti bolognese, what might be the content of that. The next step that we're actually on the brink of right now is to bring the invoicing systems into this. And by that, we can correlate and see that it's probably this kind of meat or this kind of carbs in this meal that was served on this day. So we're on the brink to get that data in, and that would massively, again, increase the potential in this system.
You have tossed food that day, and you correlate that to maybe.
Yes.
Okay.
Right now, it's pretty much a lot of guesswork based on how the chef, phrased what's in the menu.
Would serveringssvinn be what you throw away after the kids have eaten? Or what is the difference between tallrikssvinn and serveringssvinn?
So, if you remember how it used to look like in your school kitchen, there was someone serving you food, right? That's serving waste. That's waste from whatever is plated on that plate and not served to someone, they throw away. Does that make sense?
Yeah.
I have to look up the English words for this. That's absolutely clear. Thanks. Anything else?
Two things. One, you might do some simple gamification where the kids, when they go into school, can see how much waste did we do today and compare it last week or something. That could be a simple version of it. I'm also, are you looking at to figure out how much like meat or carbs are thrown out? Are you comparing kind of different days of meals where some are only carbs or mainly carbs and some are mainly meat, and then see the difference between those to kind of predict or estimate if you have another meal that is another combination of carbs and proteins?
Yes, that's definitely one thing. The second question, that's definitely one thing that we're going to start looking at even further. And you could also see that if you just twist the meals around, so you alter what's on Tuesday with what on Wednesday, if you alter them around, you might also see lesser food waste, for instance. So yes, we're going to look very deeply into that. In terms of gamification, yes, I love that, right, to have the kids compete. But I would also actually, as a part of the business model, we're playing with the idea that this is the base level price, right? This is what a kitchen have to pay to get this service. If they lower their food waste with 20% the next month, they're going to get 10% off the bill. So we're going to actually economically incentivize them as well to make sure that we play a part in this bigger change.
I have actually seen that business model done in construction, where you renovate apartments for energy consumption.
Yeah.
So you get a fixed bill for the energy consumption you have today, and then the company goes in and does renovation for free, basically. But they take the difference, the savings, for 3 years.
That's super clever, right? And especially in a goodwill area like this, it's really useful to do that. One last thing before I leave, and that is that we have tried to generalize the central model in this. So we could probably throw in a lot of other waste in this model and see what might come out. And right now we're looking at, for instance, the biggest glass manufacturer. They throw away 1,000 tons of glass every year. And that's also a massive waste. And what if we could actually throw their data into this model and see something useful come out of that? So windows, car glasses, whatever. Wherever there is glass, there is a lot of waste. feels like a shame. So let's see if we can do something about that as well. Okay. Thanks, everyone.
Right. Let's give Emil a hand.
Great. So, a lot of nice speeches today. It's been really intriguing to listen to you all. But my name is Emil Boreus, and I'm the head of data science at Enrichment. We're a startup based in Malmö, and I will talk some about our machine learning and AI journey, and what challenges we have been facing, and how we are tackle them in the sense of startup. So our journey began in May 2018. I joined in September as the second employee. So I've been there almost from the start. I was friends with the CEO prior to that, and knew a lot about the project. And we've raised some capital as well. We're at about 21 million raised from venture capitalists today, but we also raised some research capital as well. And when I started with 3 founders and me and another guy, now we're about 25 people, ranging from a lot of full-time employees, but also a lot of thesis students and student workers as well. But what we do is that we are building a software as a service tool that manage open source risks. And we want to enable companies and industries to develop better software by increasing the leverage and the impact they can bring through using open source. So we are looking at 3 different risks here. We're looking at security vulnerabilities, which is our main offer today and what we started off with. We're also looking into licensing, and since all open source comes with a license. And what we're betting a lot of effort on right now is the open source health part, which is kind of a blue ocean right now. So we're putting a lot of effort into that. But what do we do at the data science team? As you may understand, that open source is a lot of data, and our whole service is based on the data that we can acquire and how we can massage it to bring value and impact to our customer. So we are responsible in the data scientist team for some different parts of our solution. First off, the obvious one is data acquisition, finding all the vulnerabilities and open source projects and linking that to what our customers, what open source our customers are using, as well as ensuring data quality. And in terms of what we show to our customers, we want that to be trustworthy. And something that we have learned is that when building a security tool, it's not about how much security issues you find in a customer's code. It's about how good those security vulnerabilities that you find are. Because our customers need to be able to trust our tool, and if there's 40% false positives, no one will use that continuously. But we are very research focused. I'm working half-time at the university as well, publishing and taking patents on a lot of our work. But with research focus, there may be a focus drift. So we're also very heavily focused on implementation in our team. All the theses, all the research projects that we start need to become something that brings value to an end customer in production fast. Because we are, after all, a startup fighting to stay alive. And this may differ somewhat from common software development, especially when we compare what we do in the data science team to our development teams. We have a lot longer projects. In the development team in our startup, they have a horizon of like weeks, 3-4 weeks, solving customer issues, closing the next customer, developing new integrations so we can close another large customer, and things like that. While we are working on the moonshot projects, trying to stay competitive and innovate to take over the world in the sense that we are in the domain that we are. So our main goal is to actually fight off our competitors. And either we can try to out-innovate them head-to-head, which we have done in some sense, but we're working a lot with understanding what they're doing, reading their research, their patents, trying to understand how their tool works, and try to diverge into some other area of the market where we can see our product market fit. So we're doing this in a couple of different projects where we I will go through this quite fast. But we have some projects where we discriminate and increase our precision for our vulnerabilities. We are working with the continuous competitor benchmarks. We are working with the open source health project and creating metrics from open source. We're also working with vulnerability enrichment. And this one is quite cool, actually. We can replace humans in about 80% of the cases where they do analysis on vulnerabilities that take about 35 days to do. Those are security experts. We do it in 0 time. We also have a large data collection and getting all the data. Since it's a real good strength in our space and what we do, is that everything is open source and all the data is available for everyone. It's just a matter of gathering it. We also have a recommendation system, and we find our own security vulnerabilities in open source project by using a lot of different machine learning models. And looking at our achievements, we have 2 published research papers, 2 coming out before end of the year. We have filed 5 patents within this area. This one actually filed today. And we have 2 state-of-the-arts. So this one we beat quite large research group in a German university. And this one is quite cool. We beat Cisco research on this security text classification task. So we're still holding the state-of-the-art in that model. But developing all these systems, we have learned a lot of stuff that I really want to deliver to you guys if you are working in early startups and building your own AI solutions. And it is hard. It is really, really hard. We have stepped on a lot of traps and pit holes and have spent hundreds of hours on wasted projects that we could have done better from the start if we knew those traps. And of course, the largest trap is finding the right talent. This is really hard within data science because it's a broad field. It's hard to find the right competence since a data scientist. The framing of a data scientist might be impossible as it's framed today. And working with and solving the right problems that brings actual end value to your end customer. It's really easy to look at technologies and what's possible to do with the technology and what can we predict on and so on, while forgetting the end customer. So it's really important to have the capability of, with your data science teams to be friends with the sales team and actually maybe perform some sales calls as well to really understand what the customer needs are in the end. Getting stuff to production. Building stuff from the ground up, from nothing, and working with large models together with maybe another development team is also something that we have found really challenging. And in the end, when you have had some success and getting things to production, delivering value to your customers, actually getting it to production in the right way, so you're not overflooding yourself with IT maintenance, quality assurance, and reliability problems. That's not really your domain as a data scientist, and you don't really want to do that. You want to focus on innovation in the end. So looking at the talent part of the problem, you all have probably seen this one a couple of times before. Most of you might have. I know that some of you agree that this model is just should be going to the bin. And I somewhat agree, but it's a good framework to start from, where we discuss what talent do we need, not only from a data scientist, but from a startup, a data scientist working in a startup, especially in early startups. We probably want to include some business orientation as well. We might need some internal, external sales to be able to explain your models and what you want to do, and explain it to the end customer as well. You want to be able to drive innovation, not just creating good models. You need to create models that actually impact the customer, as well as getting shit to production. This one is really, really big here. Quality assurance, reliability engineering, DevOps is a large thing here, and in the end, just explaining your models through the user experience. I mean, here, this is not doable. This is not something that you can do. This is not something that you can barely expect this of one person, and this is just completely. These are all things that I have had to encounter during those 2 years, and we have solved them in terms of recruiting new data scientists in a different way. We can look at some general data science knowledge, and that's great to have, and it's really important. But I prefer domain knowledge. I like to pick students that study security rather than machine learning and data science itself, because then they have the knowledge of how security works and what's important there, how looking at coding from a security perspective. And it's easier to learn machine learning than security today. And also skills I'm looking at is data engineering is more important than data science from a startup perspective, because this is what you spend a lot of time with in the early days anyways. You also need to be very customer centric, and as I said, working with the domain knowledge. Ambition. This is something that is hard to find and hard to test, but it's really, really important to find really ambitious people. And in terms of how we do this at the Bricht, we have this term that we don't celebrate average, and this might sound harsh, but it's true. And every time we have settled for average, we have had to eat that up in the end and do some and have had to take really unfortunate actions from that. So we need to find top talent and don't settle for average. Also, it's really, really good here if your ambition to become the world's best data scientist is connected in the end value that you're creating and working together with the sales team. That is something that we have found really important. And this one is hard. This one is hard to find during an interview. It's probably impossible. But I really maybe I should call this grit. But I think that's too narrow. It's the ability to just get stuff done no matter what. If you say I need this, and you say okay, that's hard. I have these problems. I don't care. I need this, and I need this next week. Otherwise, we lose this customer. Those are going to be the situations that you encounter every week as a data scientist in a startup. So what I like to do now is that I, of course, tell my candidates thoroughly, and the honest truth is that if they don't cut it, don't keep them, and do this early on. And master theses. This is actually something that we have been leveraging a lot, and this has been great for us, because then we can learn a lot from those projects. I can have planned leadership and be vague to see that I find the ability, even if I don't frame the problem perfectly for them and serve them on silver platter, they can solve it anyways. So this has been something that's great. And it also have worked in a startup sense as a working buffer, because we can always say, here, I can pay you 30% for 30% of your job if you take this to production as well by yourself. Great. Something else that we've been looking at is, okay, not becoming overflooded with maintenance and reliability and things like that when you have been building models and deploying them for a while. So don't build APIs. This is something that we have learned. Push your data to some other team and some other backend service that can handle the reliability and uptime and all like that, because we don't want to spend our focus on that. We want to spend our focus on innovation in the end, because if you are working with data science and machine learning in a startup, that's probably most of your innovation power within that company, because it's so expensive. If it's not, you probably shouldn't do it. For us, we worked with a push architecture where we push data into our normal backend rather than building APIs. So we can have like 80% uptime on our machine learning services and they need 99.99. And everything's fine for the customer in the end, which is great. Keep focusing on innovation and optimize your time to reduce the bubbles that I showed you, skills you need with DevOps, quality assurance, and so on. Keep focusing on what actually brings value to your company in terms of raising the evaluation of your company and bringing value to the customer. And I know your customers won't care how good your Kubernetes cluster is anyways, if you in the data science teams. Do something else. And choose your metrics and how you evaluate your model from the customer perspective. Your test set is never your test set. Your customers are your test set in the end. And this is something that can be quite hard to actually perform, but hire people that are willing to talk to customers and are smart enough to try to explain the model so the customers can understand it. That's how you test your models in the end, not with a test set. Yeah, so you think if this sounds like fun, I'm hiring right now two data engineers. This is what I'm looking for. Yeah, and that's address, careers@thebrick.com, or just ping me. I'm closing it Sunday. And there was a question as well on investors. And I have a slide for that, actually. It can be quite hard to understand. It's graphical and so please follow me here. Yeah. So. Yeah. So there's if you have crossed AI with another technology, in my experience, where both are booming. In our case, open source cybersecurity, there's no stopping to how much investors like you. And we, of course, I have to say that my CEO, Daniel, he's amazing at finding capital. He's really, really good at that. But there's a lot of talk about AI when we are looking for new capital as well. So that's good. Great. Any questions?
Wow. I had a very similar role at MinDoctor. Set up the data science team there. I was interested, you said push the data to the dev team. What do you mean by that? Do you push the weights for some model, or what is the data in that context?
It can be different things, like in terms of our service, like vulnerability enrichment and things like that. Then we fetch all the vulnerabilities, we perform all the analysis, do the vulnerability enrichment, and then we push the vulnerabilities to the dev team, so they can handle, all the uptime issues and stuff like that. But in the worst case, if our service is down, we don't find the newest vulnerabilities for those days. But I mean, that's fine. Our customers won't handle them that fast, anyways.
But you run the batch processing, so to speak.
Yeah, exactly. So we have batch processes, and we manage a lot of deployments. But I don't want to manage direct customer requests.
Yeah, that's very wise.
Yeah. And we did that first. And I spent a lot of time on that for a while. I don't want to do it. Great. Any other questions?
Why Sunday? Why do you post on Sunday?
Because I have a lot of candidates in the pipeline. Okay. And I don't want to keep it open anymore because it creates too much work for me.
Do you ever go by stomach feeling at least? I mean, when you choose, you're really strict with your parameters that you can go after?
This is what I'm looking for in the end, and then of course I don't expect I don't expect too much, or I'm realistic.
Yeah. Do you do any tests? I mean.
Yeah, we have programming tests, and those are designed to test these things. Then the programming test is not that you get 2 pages. It's that you probably get this much of a paragraph and say, oh, find this data, do this with that, and send it to me.
So they do it on the interview, or?
No, they have 1 week to do it.
They have 1 week to do it. Okay.
And then just send me the software. So that's how I test them, and then I usually try to optimize those tests to test ambition and getting stuff done thing.
But no personality test like in the corporate, that kind of stuff?
No, never. But of course we have personal interviews and so on, and first with me, CEO, and so on.
Do you ask any math questions in an interview?
I could, but I don't. If I have done that for some people where I think that there's a risk, and then it's not usually the math questions I'm asking. It's more about framing data problems questions that I ask, which
how to attack a problem, or
and usually if they have a GitHub or like have done some theses or something, and I just scroll through that quite quickly and ask really specific questions, which is nice to see people talk about math in that sense as well. Yeah.
So recently I had a presentation for the AI map for Öresundregion, and now you have on your table how easy it is to get talent in this region. So do you have any so how many candidates do you have in your pipeline? So say do you think you're satisfied, or is it hard to find talent in this region?
Well, talent is always a tough question here, and I'm honestly gonna say that I'm probably not the right person to give a good answer to that. That's representative of how it is, because we are cheating, and it's really cheating in how we get talent, because we have such a close link to the university, so we handpick students from the university straight away. So that has been a good strength for us. But in terms of applications to I'd say it's easier to recruit for data than development right now, at least for us. I get a lot more applications than our development team right now.
But I would like to turn to that question as well. I mean, it's also about keeping the good talent in the region, and I can feel that, this region has it started showing tendency to actually lower rate on very smart people, on data science engineers, and that's wrong. And I mean, all this is good that we do a lot of pro bono stuff, but somewhere it must stop, because it's basically those guys and girls, they need to get really well paid, otherwise they're going to go somewhere else. And is that something we're going to have in this region and in this country? I don't think so. So this is something we have to start thinking in this region, making sure that people with those great brains and lovely ideas and actually people pushing forward AI innovation get very well paid. But that's something that society and all the big corporates and the public sector, private sector, they need to start thinking about this, and not lowering the rates, and even like investing in the startups and all this kind of stuff.
Yeah, definitely. But I think it's also a problem where there's been a challenge in general, I think, with AI and machine learning in terms of actually bringing real impact. That's why I'm focusing a lot on that, because it's really important for us as a startup. All the money we spend on something that doesn't make it to production is something that we could have spent on something that could bring us new customers and could get us runway. So of course we got to experiment a lot and take those shots. But if we bet on data science and think that this is our future, this is how we should work, then we really need to get that all the way to the customer value and really understanding what we're doing that actually brings value to our customers. And like, I won't mention companies, but I've been in contact with AI companies in the region where they have teams of like 4 or 5 data scientists, and I have one front end and one back end, and it's and there's no talk of how the end customers are interpreting the value that the data science team is delivering, and they are working a lot on optimizing the models, but there is no one working really on understanding what the customer actually wants and how they actually use the predictions.
That's the gap we spoke about, you've been helping us in our education as well. It's a gap with 2 angles, like developers, machine learning experts, they need to be able to explain their models, but then it's also the leadership board and decision makers. They definitely need to learn more AI ML to be able to understand the data scientists. So it's kind of like it's gap needs to be reduced from up and down, so to say.
Yeah.
So it's responsibility, Kaizen on all levels.
Yeah. And in terms of like, I agree. And in terms of like this in the startup perspective, the decision makers are the salespeople because they know what the customers want. That's why I'm emphasizing that we need good contact with those people.
We've been talking back and forth in many of the talks here that it's hard to kind of get the management to understand the value of machine learning, and it's also machine learning is still rising in popularity, and there are coming more and more solutions. We have a lot of things that's working, but I think the business cases have not been kind of publicized and shown the great value that has been produced. Do you see some specific challenges of convincing the management part that they should invest more in machine learning and employees within machine learning and stuff like that?
I think that is so hard because I'm honestly, I don't have the correct answer, and what the reason, that's the reason that I'm probably going to work startups for the foreseeable future, that I don't know the answer on how to actually get stuff done in large corp. And in the startup sense, you have to be entrepreneurs, but in large corp, I don't know. And it is a tough challenge.
Actually, you can be stopped doing things in big corporates if you do too much, too fast, because big corporates have tendency to kind of move slowly.
Yeah.
I've been experiencing that actually. I'm a very fast mover, and I become more take it easy in a way.
I bet you're probably a better person.
I'm like, but why? Because I'm a middle-aged man, 50 something. I don't want to kind of hold this on my plate now.
Yeah.
Yeah.
All right. Thank you,
Yeah.
Kimmy.
Thank you.
Okay, moving on to the last speaker of the evening. This is going to be cool. Yes.
So let's give a hand for David.
Yeah.
So, hi, my name is David. I'm a junior data scientist currently working at Öresundregion together with Isabella, Melina, Oscar up there, Jacob as well, and Jairo, who's not here today. Currently, I'm working at Sony as a consultant, very close, working hands-on with the technology used in self-driving cars. And today I will talk about my hobby. Have you guys heard about Kaggle?
Yes.
Yeah. Most of you? Okay, good. How many of you have actually competed in a competition? Okay, a few. So for those of you who don't know about Kaggle, I will talk a little bit about Kaggle, and then I will talk a little bit about my participation in a competition where you build a model for a self-driving car. So as most of you know, Kaggle is a community for data scientists where you can enter competitions and compete and learn a lot, and also share your knowledge and make friends. Kaggle also offers many data sets which are public, which you can test your ideas and build models on top of them. They have a web-based data science environment, actually, where you can run your code and build models with free GPU quota and GPU also, which is good. And for companies and organizations, it's a place for the organizations to host data science competitions. So you can actually let the data scientists at Kaggle to solve your problems. And then all you have to do is just to prepare the data, formulate the problem, and provide prize money for winners. And then you can use the solutions of the winner entries. And also during Kaggle's over the course of the years, the competitions have furthered the research in many different fields, such as HIV research and also in traffic forecasting. So next part is my participation in this competition. I will briefly talk about the data set and the approaches which I have used to train my models. So start by showing you a video.
Do you want me to open it?
Please.
No worries. Do you want sound?
It's okay.
Okay, good.
So I'm just gonna. That gave me a lot of joy when I watched that video the first time.
Yeah.
I was very passionate about creating a model which could do the same thing. So how does this thing actually work?
Oh, you have to. I think you have to minimize the. Oh yeah, let me do that.
Sorry.
No, it's fine. It's just like this. Okay.
Okay, so this competition that I'm going to speak about is the Lift Motion Prediction Challenge for autonomous vehicles. Stand here. So the ride-sharing company, Lyft, they are actually going to build a complete self-driving car. And they have hosted this competition on Kaggle. Last year, they actually hosted another competition called Detection of 3D Objects in Traffic. And this year, they are hosting a competition for motion prediction. What is motion prediction? It is basically, imagine that you have your self-driving car here. This is called the ego. And you have all the different agents in the environment. Motion prediction is basically you predict the trajectory of the other agents in the future. Basically, Google Maps on steroids. So you have to do this very quick and accurate in order to avoid traffic accidents and correctly plan your route. Motion prediction is actually a part of Lyft's pipeline. It looks like this. They start with gathering data from the car. So they use LiDAR data and cameras to capture images and 3D points. And then they do 3D tracking of the objects to localize all the different agents in the environment and classify them as pedestrians, cars, or buses, and so on. The next step they will use in the pipeline is motion prediction, and then finally the trajectory planning. So this competition that I participated in will focus on motion prediction. So basically, the task is that we will predict, using historical data that they have gathered, we will predict the trajectory 5 seconds into the future using the historical data, and for each agent in the vicinity of the self-driving car. So this is the target we're aiming for. We want to predict the coordinates. Yes. The data set which they have is currently one of the world's largest data sets on motion prediction. It contains over 1,000 hours of data. In summary, what you see on the right there is actually a scene. This data set contains over 170,000 scenes, where each scene is 25 seconds long, and each scene contains many agents. So basically, the data set is very huge. And the thing is about this data set is that this data set covers only a point in a city from A to B. So it is not a general data set. It only covers and is annotated from a specific location, A to B. So that's their plan. So we'll start by modeling the simplest model. What is the simplest model you can create, which predicts the trajectory of cars? The simplest is constant velocity model. What is that? It is basically a model where you have the car and you have the velocity. And then you interpolate the trajectory into the future and predict where it is, but with only the velocity. But is it good enough? No, it isn't. There are many problems. For instance, in those simple cases where it drives straight forward, works really well. But when the environment changes, like that curve there, it might drive into the other lane and cause trouble. So this simple model, it doesn't take into vehicle dynamics, doesn't take into road lanes, road signs, traffic rules, and also other agents in the traffic, and a lot of more. So we need to build a better model. One approach which many people are using for this competition is to firstly annotate the data, convert it to bird's eye view format. Basically, you encode the information from the traffic into a 2D image where you can set different colors for the different types of data. So you can color code the traffic lights with this white stripe here. The agent which you're predicting for is red, and the other agents are yellow. Or you can separate them in different channels. So what I did was I prepared the data in this format, and then I fed it into a convolutional neural network directly, and it outputs the trajectory. This model worked quite well, and I tried other approaches, such as encoding all the agents in a traffic scene as 3D points or cloud data. And then I used a model called PointNet, which can take, the interesting thing about PointNet is that it can take arbitrarily long an arbitrary number of inputs and summarize them and give an output. So I tried this model as well. But in the end, the final model, which performed the best after my model comparison, was actually the first one, with the bird eye view. So basically, you separate the data in different channels. This is what a channel is. So instead of having everything in a single image, you separate them into different channels. And you feed it into the neural network and predict the trajectory. I submitted this solution and got the position of 24.
Out of how many was it? Like 400, 500 something?
300, I think.
Okay.
Yeah. So this was 1 month ago.
Yeah.
And some interesting findings for those who are interested in deep learning and this type of problem. So I noticed that using the bird eye view model, it is actually better to use shallow models. And what I mean is, usually it is good to use deep model because a deep model can capture frames better than the shallow models. But apparently, shallow models work better for this type of problem. I tried other backbones as well, such as Efficient, and that didn't work at all. I tried different loss functions, but negative log likelihood loss function proved to be the best one for this problem. The model actually learned better. Thank you for listening.
Questions?
How do you feed the data to the neural network? Do you feed it per layer, or do you feed all the layers at the same time to one neural network? Or do you have several separate neural networks that are used for each traffic layer? Or how do you describe it?
So if we look at this image here, so usually a model takes, usually a CNN takes 3 images, one image. And one image is actually 3 channels, RGB. But in this case, you just feed it 25 channels, which is, think of it as an image, but with 25 channels, like RGB and 22 more. Yes, so basically that. And then you have a normal CNN, and you output it, the trajectories.
So how many outputs do you have?
So in this case, you output the XY coordinates, 50 XY coordinates, so in total 100. But you want, in this competition, you actually want a multimodal output, which means you want this model, you want it to output 3 or more trajectories at the same time, and then you can put like a probability on each trajectory, which path will it most likely take. That is another approach. So what I'm showing here is just an output with one trajectory, 5 seconds into the future.
These look really similar in different separations here. What are the differences between the, say, the top left ones?
Sorry, I didn't explain that properly. So we are actually looking at 1 second of historical data. So these first 11 images are the agents in the traffic. So what you're seeing is different timestamps of data. And then here, you can see the actual agent in different timestamps. And here, we have encoded the road information. So like you can see traffic lights here. Here you can see the road lanes, where you can drive and cannot. And also, no traffic sign available. But yeah, that's about it. So that's how the information is encoded. And we want the model to learn to capture this data and predict the future. Yes.
So the end result is basically an image where you have a position for each of the cars, or how do you track which car has been moved to which position?
Sorry, do you mean if the output is an
image? Yeah, about the output. Yeah, the output is these 50 coordinates. But I suppose that the 50 coordinates represent 50 cars in this image, and if you only have 10 cars, then only 10 of the 50 will be filled with some data, or as you mentioned, they will have like 3 different positions for each car with the probability. Or are you looking at a particular car? What kind of the output? What are we looking at for the output?
So what we are looking at is, for instance, let's take this car, this red car.
Yeah.
What you want this model to do is to draw like the arrow where is it going in the future.
So you mean it's only looking at the agent?
Yes, one car at the same time.
So when you look at one of the other, the yellow cars, you make that the agent, and then you look at that car and predict how that is moving.
Exactly. Yeah.
And the 50 points are kind of stepwise.
So it's like
or a spread of 50 possibilities where this car might end up.
It's where it will be every 10th of a second, 5 seconds in the future. So,
okay.
Yeah.
Then I get, yeah.
It's super. Okay.
May I answer? I'm a complete amateur, not a data scientist, but I'm just wondering, why is it important to be able to predict what is happening in traffic? If you look at a human being, as I'm driving, I'm not able to predict 100 scenarios. I act on what is happening, what I see on the road. Is that not possible to work that way with this data science as well? Or is this to make it really safe or secure? Why is the reason why you need all those predictions?
We want the model to actually do what you described. We want the model to react like we did when it's autonomous.
Okay, but when I come to the crossing there, I see certain things which make my judgment based on one thing happening, not 100.
You are predicting.
I think I have an answer. And you are a human being.
Yes.
And you have learned a lot over the years, so you can predict which things are important to look at. You know that the car standing on the side won't drive out and hit you, but the machine has no concept of what's going on in the environment. So you basically have to tell it every single piece how they interact, and then you can kind of use that to predict the situation. And that's why it's so hard for these kind of algorithms to make self-driving cars, because it's a completely different set of logic. You need to turn like a messy world into logic to make it work.
That was a good answer. Thank you.
Thank you.
I think it's done before.
Yeah. So these machines do not think; they just act on mathematical equations.
Okay.
So we have to teach the mathematical equation to know what we humans see. Yeah. All right. More questions?
I have a question about why is bird eye view an important thing for Lyft in this case? Because I assume that this image cannot be built like from the cameras around the car, right? Can it? I mean, it cannot like can it transpose this into the bird's eye view? Because if you solve it, if the problem is solved in the bird eye view, how can that should be translated back into the car when it's driving itself if it doesn't have the bird eye view itself? You understand what I mean?
LiDAR is perhaps sort of like bird's eye view. What do you think? No, the thing on the roof is a radar, a laser radar.
Oh, okay.
But the car is connected to the Google Maps.
Real-time satellite images.
But LiDAR is the
vehicle-to-vehicle communication is also planned for the future. So actually, if we share your position, never enough. You might actually be able to build yourself.
If you look at the image here, you see that some cars get smaller and then they scale up as a bus.
Yeah.
That's the LiDAR that detects just a piece of the bus and thinks it's a car. And then it's actually a bus. So it's actually LiDAR images turned into this topological view.
So yeah, it is like if I show you this image, the first step is to like capture information from the environment and then create this bird eye view from this data. So
does this mean that it's very important for the car to actually know exactly what the road looks like in the future? So if there is a traffic work or something, it's very important that that data is accessible for the car. Is that so?
Yeah, it is important. So we want the, for instance, when it comes to like work on the road, we want the data to contain a real world distribution. Like we know that there may be work on the road, so we need the model to learn that from the data. We need this type of activity to be inside the data as well. So you have to think about that as a data scientist, to have a data set which contains the real world distribution. It will not be able to work if you are missing something from the data set. So it will not be able to perform well if it sees a scene it has never seen before. Yeah.
So it's only important if you want to survive. I'll drive myself.
There's a question up there.
Yes.
Did you, I assume you did, but look at the other contestants and what kind of models did they use for solving this problem?
Some people use like the tree boosting algorithms, building decision trees based on the data that they gather from the data set. So I didn't actually look at further into those models, but this approach was pretty interesting. This approach, PointNet, I actually saw someone else use it, and then I wanted to develop my own ideas into the model. This model is pretty interesting. It actually takes points and any number of dimension, an arbitrary long amount of inputs as well. That was pretty interesting. So if you have 3 cars, you can just feed in 3 cars into the model. It will be able to output something. You can also input 10 cars, so you can feed in arbitrarily long number of inputs. That is very cool with PointNet. So I looked at this, and also I didn't mention it, but you can also use LSTM and RNN networks to train this type of data as well, because you are using historical data, so you can use the velocity maybe, and then predict the future. But I only looked at PointNet and the CNN bird eye view approach.
And what is the final submission? Or is that 1 month left or something like that?
Around the end of November.
End of November, yeah. So you still have time to make it top 5.
We'll see how that goes.
Yeah.
I don't expect much. I find it really fun to do this. It's cool to be able to model.
Are you still working actively on it?
When I don't have anything else to do.
Maybe it's really not a long time, just kind of submitting the AstraZeneca competition within 1 week. So yeah, like we have to actually put a reminder on his so he actually goes and sleep. Isabella did it. Yeah.
Does it require a lot of computers, or is it possible to make in a laptop, or what kind of power you need for that?
Actually, for this model, it is very hard to train on a laptop.
Yeah.
Okay.
When I trained my model, I used like 5 or 10% of the full data set because I didn't have the resources to use the full data set. The full data set is so large.
Okay.
Yeah, so you need GPU, a lot of RAM, GPU RAM, and then you need many CPU processors to parallelize the data preprocessing.
Is that a factor in determining your ranking in the competition? How sparse it is, or how little power you need to use to compute your model?
That's true. And many competitors don't have access to resources, so they may have greatest ideas, but they don't have the resources to build the models. So actually, in this competition, Lyft is sponsoring like the 300 first competitors which achieved like a score beyond that certain threshold. They will give out $300 for free to use Google Cloud Platform.
But you wouldn't gain extra points for being able to run it on less GPU power, for instance. So it's not a parameter in deciding your ranking.
No.
No, okay.
Just.
But it's not possible.
Wouldn't that be cool?
Yeah, I think about yeah, it would be, but then again, it takes what it takes to run a model. It's not having control.
There are academic competitions like that, where you compete on energy budget and stuff like that.
But then it's basically the ML edge on the, I mean, basically you need to run everything in the, yeah.
CPU sustainability.
Yeah.
How long do you take to train a model? Like 1 round of training or iteration of training?
You can't even go through the whole data set.
No, yeah, like with like part of the set that you used.
So I trained for 1 week and I went through 10% of the data set.
How many models did you try?
Around 11.
So you spent 11 weeks?
I tried to parallelize the activities as well, in order to get the most insight out of the trainings. But yeah, I spent much 11 weeks. Any more questions?
Okay, I haven't seen any questions on the YouTube. Thank you, David. I believe this was the last speech. I don't know if we had the last slide. So before you leave, guys, just a couple of things. So what was the race? So, all right. So yeah, thank you very much for being here with us. I know it took a little bit more time than we actually planned. Just a little bit. Hello. Just watch out for this one. So a new one is also in the new one. You're there. Ah, that's safe spot. Okay, so you can stay in touch with us. You already noticed us on different social media channels. But I would also like to make a note that we will have more of those speak corners. Like we said, the next one is in Prisma, January, February. I don't know, Stella. We'll just plan to see when we can do this. But if you have, if you already know, I want to present something, just type us.
Yeah, and I mean, it doesn't have to be this serious. I mean, I showed cat images.
Yeah.
So.
Yeah, and this is very strict, but maybe we just need to kind of get used to having those cameras and then sending live. It's a good practice as well. Like if you're not a public speaker, and many data scientists struggle with, telling, people what they actually work on. And this is a perfect, community. Go ahead and go all wild. Nothing can go wrong. I mean, Sabella already did. Yeah. So just, relax and contact us. If you have any other ideas, like we would like to have a Carol competitions again. We had one,
or like exactly some type of hackathon, like beginning of next year.
Yeah.
So if you have any ideas or wishes that you would like to solve this and that problem, just let us know.
Yeah, definitely. Johan, do we have anything else?
Yeah, we would like to thank Helsingborg Works for the facilities and Joachim Jardenberg for the video and
the perfect streaming.
A big round of applause for them.
Yeah.
And all the pictures, of course.
Yeah. Really, I hope you learn a lot and we do so much cool things here in this region. I mean, realize that now. Yeah. All right.
Yeah.
That's all. We can go and sleep.
See you next time.
Yes, thank you. Thank you.